Good morning, everybody, and welcome to those of you who've waited so patiently for this event. Many apologies. We've been having technical issues with the software that we utilise. It's completely beyond our control. They've managed to fix the software and people are now joining the event. If you'd like to sit back, make yourself comfortable, we will shift the start time of the event to 9:45, and that just gives chance for Tom, the secretary, to send an email to all those people just to let them know that the event has been delayed by 15 minutes, the start time. So many apologies. The event is operational. We will be going ahead in just a few minutes. My name is Simon Woodward. I'm the chairman of the UKDEA, the UK District Energy Association, and this morning we'll be presenting, and we're very excited to present our second Innovation Showcase Event number 2. It only seems 5 minutes since we were doing the first one, but that was a year and a half ago, way back in spring 2021. So just to explain a little bit about who we are, whilst we're waiting for other people to join. So we're a non-trade, not-for-profit association, and we were formed back in 2010 by 6 founder members. And those 6 founder members were largely local authorities, and those people wanted a voice for district heating, district energy in the UK. And we have risen, or we've grown dramatically since 2010, and we're now approaching 150 members, and we're growing rapidly. So there's a couple of little images on the right-hand side of the slide. The lower image is the one which talks about how we're structured. So in the centre of that are the scheme developers, owners and partners. Those are the full members. Those people who actually develop the schemes themselves. They might invest in schemes, they might enter into long-term energy supply contracts, and around the outside are the incredibly important associate members, ranging from equipment suppliers, installers, service providers, etc. Then the image at the top just gives you a sort of a picture of the breakdown of the membership. So we've got energy services companies, contractors, and local authorities, LASCO, so the kind of people who are developing the schemes or building the schemes, and they make up about half of the membership. And the other half of the membership is made up of manufacturers, equipment system suppliers, consultants, and legal advisors. So those people are selling services into those people who are growing schemes. And just for those of you who have joined us, thanks very much indeed. I know more people are joining us every minute. We'll be kicking off properly in 9:45, so I'll just slowly work through the introductory slides, and then we'll kick off with the actual event in just a few minutes once we've managed to get everybody in. And apologies again to those of you who've only just joined. We have had some problems with the software that sits behind the event, which is beyond our control, so apologies for that. Then in terms of what we offer, member benefits, so we offer a lot of benefits to members. On the right hand side there you can see a couple of pictures, the front covers of our more recent monthly journals, and those are sent out every month to members. There's a 50-page monthly journal, but there's many other benefits. You'll be involved in a collective of 150 organisations who work together, networking, discussing problems, discussing issues, talking, coming together in events like this. And through us, your voice is heard by central government. We correspond with government almost daily. We meet with government at the highest level monthly. So it's a very good opportunity for you to raise your voice through us to the government. You'll also receive regular updates on all of the things that are going on in terms of policy and regulations, which is very important in this very changing energy market. We've got an annual conference and AGM, an in real life person event we're planning in early 23. And we've got webinars like the one this morning. There's also a website that we operate, and there's a library that sits behind that, which is accessible once you're a member. You can have regular advice, support, and help through member meetings. We have a jobs board where you can advertise vacancies on the jobs board, and if you offer training, that can also be shown in our training register. So again, please do consider taking part. And just a little bit more about the training register. That's not the feature of this morning's event, it's the Innovations Showcase, but there are innovations we can talk about in the training register. It's a really valuable resource. It's over 50 pages long. We've got 26 different UKDEA members offering courses, and that's on our website. And if you'd like to get involved in the training register, please do. Anybody who's a member of the UKDEA and offers a training course is eligible to put theirs in the UKDEA training register. So please think about doing that. So today's event, again, apologies for the late start. It's a sequel to our first event in March 2021. We've got around 200 registered delegates. I have to say I'm stalling a little bit for time because I know a lot of people were waiting outside while the software's just getting livened up and we're getting more people into the room. We've got 3 themes this morning, 3 really interesting themes ranging from water treatment through to technology. We've got 15 presentations. Each of the speakers will be presenting 6 content slides and they're each 10 minutes each. And that's really, really important. We want to try and keep that as short as possible because of the delays we've had starting the event. If you want to ask questions, please put those in the questions tab over to the right-hand side of your screen at the bottom. The chat area is for just general talking between yourselves and the speakers, but if you've got a question, we'll try and put it to the speakers during the event, but if we're running out of time, we will follow up with those afterwards. And remember that the presentations are a taster for the innovation. They're not a full sales pitch from the company, they're just a taster as to what the innovation is. If you want to find out more, please do contact them. Really importantly, the event is CPD certified, so that's really good news. And when you get the email following the event, there will be a document that you can download, and the access code is 02112022. So please do enter that access code to download your CPD certification certificate. So without further ado, I will hand on to the first speaker, and the first speaker is Alexis Wheatley from Elysator. So Alexis, if you'd like to come and join the stage and talk about your exciting innovation, next generation of water treatment. So over to you, Alexis. Do you just want to kick off and then I'll leave once I can hear you okay?
Lovely, yeah. Can you hear me okay?
Perfect. Thanks, Alexis.
All right, thank you very much. Thanks everyone for the time today and the opportunity to talk you through what is the next generation of chemical-free water treatment. Just a quick introduction for Elysator. We innovated this technology and started using electrochemistry to be able to deliver corrosion protection in closed-loop systems back in 1970. So for the last 50 plus years, we've been operating in land-based projects, and in the last 30 plus years, we've been dealing in the maritime industry. And it's in fact our maritime partner, IWTM, that has developed the Protector series, which I'm going to be talking about. If we look at the causes of corrosion, first of all, any one or more of these elements within your system will result in corrosion. So oxygen, pH when out of range, high conductivity, sludge and debris within a system. We have a current chemical-free water treatment and it's a 2-phase solution. So we have the Elysator, which is a reaction tank, and you can see there it's quite a wide body, and that sits on the flow around a working pump. Central to that, you have a sacrificial magnesium anode, and as water passes through the unit, those sacrificial magnesium anodes sacrifice themselves, so they corrode and they scavenge and consume the dissolved oxygen in that system, and they take that down to 0.1 milligrams or less. This then releases magnesium hydroxide. That's the chemical reaction that you get from the anodes. This circulates around the system and then elevates the pH to the required levels. What then follows through is you have demin water that's in that system. That acts as a natural cleaning agent, and that agitates and puts into suspension the sludge, slurry, and the fixed debris around that system, carries it round to the reaction tank, the Elysator, ready to be blown down in the ppms. And then what we have is we have the demineralizing unit, which is the Puritap, and this engineers the mains fill water, and this sits between the cold mains inlet and the pressurization unit, and this engineers the raw fill water coming in, raises the pH and gives a zero conductivity going into that system. So you're always using best practice. So this is our next generation Protector unit, and these units offer a host of new features which assist and aid with the faster correction of water quality within existing systems, and then a much higher level of protection in new systems. So, and this is good for both new and existing systems. Doesn't matter what kind of closed loop it is, as long as it's a closed loop. So LTHW, chilled water, district heating networks, etc. And it's an all-in-one solution. So it provides that filtration whilst it's engineering that water. It comes complete with a full installation kit, so you have your valves, your meters, etc. That comes with that standard, and we've also redesigned the demineralizing units that come with that, the Profil range, which offer advantages to the speed at which you can now service that equipment. So the protector range consists of the P10, P25, P40 and P70. We've got a 120 that will be joining us next year, and the P10, the number on there denotes the thousands of litres that it's designed to take care of within a system. So the P10 is a 10,000 litre system, P25 is up to 25,000 litres, and so on. And this is for a heat network. On a chilled network, because you don't have the advantages of the heat, then the chilled network on there is has to be sized up one level to be able to take care of the bacteria that the heat actually kills off within that system. So on with the operation of the system and the advantages it creates. So we have a longer, thinner body on the protector, and that offers us a number of benefits. As the water comes in through the system, you get a far faster rate of circulation as it's pushed into a cyclone in that unit, and that assists with the separation. So it expels the air to the top of the unit, ready to come out, the micro air bubbles and the air pockets to the top of the unit. So it's faster separation there. This then gets released through the AAV, and then the non-magnetite particulate in that water is forced out because of the pressure it's under. That hits the 40 micron basket that we have in that unit, and then slides down to the bottom, ready to be blown down as part of the normal ppms that you would have with our units. So that 40 micron basket that we have offers a number of advantages. Obviously the higher speed, it assists with that particulate, which on a wider body system, if you had it traveling faster, it would just push out the outlet, and so it would take longer to clean through that system. But VDI demands that you have the anodes encapsulated, and on existing systems, that is a mesh that sits around the anode, more localized. And the issue we have with that is that inevitably, when we replace the anodes, you've still got a lot of magnesium left within there that's not being used. So having that basket sitting within the system, which creates that encapsulation, and having the separate anodes unsheathed, allows us to be able to burn right down to the wire. So you've got no waste happening within that system. Filtration is also a requirement for VDI 2035, and so we have a number of bag filters that can be put into the system as well, and that can create finer filtration. So that can take you down to 1 micron. And what you'll see there in the second image there is on the front, you've got the pressure gauges, and these pressure gauges will indicate the differential in pressure on will indicate when those finer filtration bags need cleaning or replacing on there. Then if you look at the third image, what you can see there is you can see the magnet and the anodes running almost the length of the inside of the vessel. The magnet sits in front. It's a very powerful neodymium magnet which sits in front of the 2 anodes, and that magnet and the anodes running the length means that you get a lot more efficient contact with the surface area of the water and the anodes and the magnets, and that means that you're pulling out the magnetite from that water at a lot of faster pace, It's also protecting the anodes and ensuring that none of that magnetite goes onto the anode surface, therefore restricting its efficacy. And then on top of that, you have the surface area of the anodes being able to grab and consume the dissolved oxygen in the water at a lot faster pace, and also not just that, but you're then pushing up the pH and raising the pH, so you're changing the levels in the water at a far quicker pace. And then the final image on there, you can see that you just pull that magnet out from the center of the unit once you've closed off the inlet and outlet, and that magnetite will drop to the bottom of the unit, ready to be blown down out of that unit. This is part of our continual innovation that we're putting into place. And as you can see here, we have the Clearview unit, which is another part of the innovations that we have delivered in the last 6 months. This is a real-time monitoring unit for chemical-free parameters, and it's BMS compatible, so it'll actually report directly into a BMS system. And we've got this installed on Barking Dagenham at the moment. Sorry, Barking Riverside. And then we've got more innovation which will be coming out in the next 6 months. Basically, we are chemical free is recognised by the majority of the major authorities out there and standards for water treatment. So this includes Heat Network Code of Practice with SIBSI. David, our MD, sat on the steering committee for that, and they've embraced VDI 2035, and even in the design guide recognised it as the best approach for large networks and low and intermittent flows. And we've got a full process for pre-con, fill and clean, which the last project was Oval Village, which it was used on there, and we achieved VDI immediately with a new water treatment contractor on there.
Super, lovely. Alexis, can I ask you to wrap up, because we're in a bit over the 10 minutes now.
And then finally, there's a full set of guides, case studies, whatever you need to understand. Any questions you have, please contact me through the info app or via the website, and we're happy to introduce any of the guides that we have on there as well. Thank you very much.
Thanks very much indeed, Alexis, and thank you very much for trying to keep to the time. And apologies for people that were running late. So, Alexis, if you'd like to step off the stage.
Lovely, thank you.
Thank you very much indeed. And we'll now go on to Stephen Peet from Flamco. So, Tom, if you'd like to pull Stephen's slides up onto the stage. And if you'd like to come onto the stage, please, Stephen. Thanks very much indeed. So if you'd just like to kick off your presentation, check I can hear you okay, Stephen?
Yep, can you hear me, Simon?
Perfect, no problem at all. I'll leave you be. Thanks very much indeed.
Great, thanks for the introduction, Simon, and good morning, everybody. My name's Stephen Peet from Flamco, and this presentation is on the control of water quality and pipework corrosion in heat networks. And it's quite a topical subject at the moment. In last month's SIBSI journal, there was an interesting article on the importance of monitoring water quality in heat networks, and the article suggested as many as 15% required unbudgeted remedial work in the first couple of years due to a lack of understanding of the importance of maintaining water quality in water distribution systems. So this presentation focuses on 4 key elements of the water treatment program, which along with continuous monitoring will contribute to a reduction in reactive maintenance works, HRU servicing time, and major equipment replacement costs. So there's some excellent guidance and standards and best practice available. There's BG 50 2021, which has just been revised, and that advises on the water treatment program post pre-commissioning and cleaning of systems, and it refers to pre-treatment of fill water, removal of dissolved gases, chemical water treatment, pH management, solids removal and filtration, as well as bacterium biofouling inhibition by biocides. Then we have BG 29 2021, again, which has been revised, and that's pre-commissioning cleaning of pipework systems, which is achieved through a process of flushing and chemical cleaning, followed by the addition of biocides and inhibitors. Since really it's impossible to directly examine or post-clean internal surfaces, the success of pre-commission cleaning is usually inferred from water samples that are analysed across a range of parameters, includes suspended solids, iron and bacteria levels. It also suggests that water treatment comprises a number of techniques, including side stream filtration, degassing and dosing. Then we have the CP1 2020. So there's some big changes in minimum requirements and best practices concerning water quality, and it's much tighter than the 2015 version. Then there's VDI 2035, which is a German engineering directive mainly used in countries in Europe, and this directive is really applicable to closed heating systems as a means of avoiding scale and corrosion. It includes an option whereby the final clean water and all top-up water that enters throughout the life of the system is demineralized, de-aerated and pH controlled. Then we have Part L, conservation of fuel and power, and soon to be released BG82, which I think comes out from Bishra on November the 8th, which focuses on the pressurization of heating and cooling systems. So really, in summarizing this guidance, it suggests if the first 4 key elements of the water treatment program are addressed, i.e. the hardness controlled, corrosion inhibited, pressure maintained and particulate contamination minimized, then there shouldn't be any barrier to effective microbiological treatment, and thus avoid the risk of not only Legionella proliferation but poor water quality. It suggests that if any of the first 4 elements of the treatment program are inadequate, the effectiveness of the biological treatment and therefore water quality may be impaired. So it's really necessary to have a combined approach to tackling all potential issues, leading to a better chance of long-term system integrity. So there are a variety of methods for removing air. We'll start with air and improving our water quality. There are automatic air vents, inline air separators and vacuum degassers. One of the major problems in systems is dissolved air in the water. Water by its nature absorbs gases easily until it becomes saturated, and that saturation depends on the pressure and temperature of the system. At low pressures, less gas can be absorbed. What we utilize is in vacuum degassing. It treats the water from system in certain specified amounts. The water is subjected to reduced pressure, releasing all the dissolved gases, and the degassed water is returned back to the system where it absorbs further air it meets in the pipework. That saturated water is fed back to the degasser and once again subjected to a vacuum to remove the dissolved gases. So it's really impossible to predict where air will be released in a system, and therefore an important reason for choosing a vacuum degasser over an inline deaerator, which we also supply to. The Vacuum Act Eco shown in the right-hand part of this slide is a unique product as it monitors both pressure and temperature. The degasser automatically chooses the most cost-effective vacuum for optimal deaeration. So it removes air at the rate of 1,000 litres per hour, and it's much better for the much bigger systems and particularly heat networks. We measure the temperature and pressure, so we operate to a much higher temperature and pressure range, all the way up to 90 degrees C, maximum temperature at point of connection. The 90 degrees C comes from the fact we can drop the pressure to atmospheric pressure. Water boils at 100 degrees C, and that's why we have that limit. Also, at the other end of the scale, we can operate around at 10 degrees C, pull a vacuum all the way down to 0.2 bar, and that's really removing all the dissolved air which is in the water, which is the problem in the systems as it comes out. It degasses when required. There's a gas sensor at the top of the unit which samples the water, switches the unit off when no gas is detected, and that's why we refer to it as the Vacuum Act Eco. So that's air in systems. Then we take a look at dirt separation. First area of protection is a fairly standard product, a filter strainer, which protects key components, removes dirt particles. However, if not maintained, there's a energy penalty there. Traditional dirt separators utilize brushes, blades, or other obstructions that slow the water flow down and aid in dirt separation. If not maintained, the blades and brushes become coated with debris and increase, again, the resistance in the system, and there's a penalty for that. Then we have a couple of options. We have side stream and inline separation. So to help with the maintenance issue, the latest air and dirt separators on the market do not have brushes, blades, or other obstructions that slow the water flow. Instead, a double thrust function is used, and in that process, the first thrust effect is created by a separation chamber that separates the contaminated water. The second effect is created by returning that clean water back to the main flow again via an injection point, which pushes the bubbles and the dirt particles in the water to the outside of the chamber where they're separated again. This way, many of the micro bubbles and dirt particles are propelled to separate plenum chambers, which help produce an exceptional level of dirt and air separation. So we take, similar to side stream filtration, 10% system flow to achieve 40% air and dirt removal on each cycle. And then we have side stream filtration, which is, again, a partial flow method through a filter or strainer. Again, another advantage of this, there's very little resistance in the system, but may take a little bit longer to clean the system rather than an inline unit. So that's air and dirt. Next, we have scale removal. Accumulation of scale also reduces the efficiency of the lifespan of the system. In part L, it suggests a chemical water treatment formulation should be added to the primary circuit to control corrosion and the formation of scale and sludge. We at Flamco use a natural electrolytic process to prevent limescale encrustation. The unit imparts a tiny amount of soluble zinc, which interferes with the crystal structure of scale, forming water hardness minerals, so they can't form a hard stubborn scale on pipework. Again, it's a really low maintenance way to protect the system against the damaging and expensive impact of limescale. So one way we can reduce reactive maintenance works and servicing time and major equipment replacement costs is by reducing human error by automating parts of our water treatment program and combining approaches to improve water quality. A way of doing that is with this compact, totally enclosed combined digital pressurization unit with vacuum degasser and inhibitor additive tank. And this will provide a minimum system pressure requirement, effective dissolved gas removal, while maintaining also the system fluid balance, inhibitor fluid balance. What happens is the correct fluid mix is blended on demand at the time of system top up. Each time the unit tops up the system with water, it also automatically adds additive from a dedicated tank at a predetermined rate. Therefore, it helps to reduce reactive maintenance intervention and maximize system protection. So if there's any questions, that's the end of my presentation. Thank you for your time.
Thanks very much indeed, Stephen. That was really helpful. Very interesting presentation, and thanks very, very much for keeping to time. Much appreciated. If any delegates do have any questions, could you please put them in the question sessions? I see that Alexis had one that was put in the chat and he's responded to it. But if you've got any questions for Stephen, please do put them in the question session. So Stephen, thanks very much for speaking. If I can ask you to step off the stage.
Sure.
Tom, if you can pull Stephen's slides down, and we'll invite Chris Hobbs from BWT to join us. So Chris will be talking about chemical-free water treatment from a slightly different angle. This is looking at from BWT. We appreciate there's a few presentations this morning which have a slightly similar content, but we thought that chemical-free water treatment should be giving an airing this morning. So Chris, are you there and available to join me on the stage? Just check that Chris is in the room. Says Chris is getting ready, so we'll give him another few seconds. And maybe you have to exit and join again. I know there's been a few problems that speakers have been having with the software this morning. So hopefully you'll be on the stage in just a second. Once again, apologies, we're running about 10 minutes behind schedule for this event this morning, but thankfully we've already had two very interesting presentations, one from Alexis Wheatley on the Elysator range, and secondly a very interesting presentation that I find quite intriguing from Stephen Peet, looking at what Flamco can offer in the way of innovations and in terms of the different ways to clean pipework. So Chris, brilliant, you've joined us.
No, sorry about that. I did have to log back off and back on again. Apologies. We've all got some technical issues today.
I won't make an amusing quip about the fact that you're out driving your nice sports car behind you, but
no, I wasn't. Unfortunately, I'm not fast enough
No.
for that one, I'm afraid.
Okay, no worries. Over to you. I'll leave you to make your presentation. Thanks very much, Chris.
Good. So thank you very much. To carry on, I guess, from Alexis and Stephen there. My name is Chris Hobbs. I'm Sales Director for BWT UK. Thank you all for your time today. For those of you who don't know us, BWT stands for Best Water Technology. Our name defines our vision. We aim to be the best. We make improving water our mission, and we do this through the application of cutting-edge technology. We are a global business and leaders in water. Given we're everywhere, we tend to look at the world as a whole, especially where we share its water. And we have a drive within our business to help change the world sip by sip, we say, meaning little by little will help to resolve its problems. We are in this instance instrumental in the foundation of VDI 2035 that was mentioned earlier by Stephen. This is a standard applied across Europe and is rapidly becoming a way to treat heating water. The thrust of this standard is towards prevention of corrosion through purity rather than a costly and environmentally damaging cure through chemicals. In the next few slides, I'm going to talk you through the corrosion problem and how BWT and our products can help you and change the world sip by sip. So corrosion happens, as Alexis pointed out, due to the movement of protons and electrons. Mineral in the water conduct an electrical charge. If you see the corrosion and deposit chain outlined on the left, three components are needed within this chain. Oxygen, which is negatively charged in pink, enters the system. Metal, which is outlined in blue. These have a positive charge. Over time, the metal and oxygen will react and oxidation and corrosion will occur. This can be further accelerated as the metals have their own particular vulnerabilities that can be exploited with a third thing, which is impure water conditions. These conditions are listed on the far right. So when the heating water is, for example, too conductive, containing dissolved minerals with differing electrical charges, this accelerates the corrosion, the impure water acting like a medium of exchange. And you can see there are many vulnerabilities listed, but mostly the water should be under 100 microsiemens of conductivity and within 1.5 degrees of pH 7. Additionally, impure water leads to deposits as the minerals dissolved within the water crystallize to form scale and provide both a foothold and nutrients for bacteria and biofilms. These cause additional damage, as we're going to explore in the next slide. When that comes. Next. Oh, there we go. Listed here, we have the various types of corrosion and deposits that can affect a heating system. And this slide outlines how demineralized water is a cure-all that breaks the chain of these corrosion and deposits. Firstly, we've got chemical corrosion. This is caused by chemicals in the water, but mostly oxygen. Chemical-free water treatment removes these chemicals, therefore inhibiting corrosion. Traditionally, degassing, oxygen scavenging through inhibitors or sacrificial anodes is used, but a correctly specified filled and maintained system should prevent oxygen ingress. Removal of oxygen, as you can see in pink in this diagram, is the first step to break the corrosion chain. Secondly, electrochemical corrosion is caused by conductivity, especially a problem where dissimilar metals are present and where there are minerals in the water. This is usually addressed with chemical inhibitors, but instead, simply demineralizing the water eliminates the conductivity. If you remember those dissolved minerals with differing electrical charges from the last slide, they're gone, and so the corrosion is stopped. Thirdly, biochemical corrosion happens where microbes excrete chemicals that corrode the materials they live on. They can be killed through pasteurization, but this is difficult to achieve in modern systems, and so biocide is frequently used. This is not a good idea. Biocide is a killer chemical. Demineralized water, on the other hand, doesn't have any mineral building blocks that the bacteria need to grow. And so it's a much safer route to inhibit biochemical corrosion. Deposits, though, can also be problematic. Most of you will be familiar with lime scale. 1 degree of carbonate hardness holds up to 18 grams of mineral lime per meter cubed. In an 80,000 litre system, this is 28 kilograms, or the equivalent of that German Shepherd dog there, clogging up your heat exchanger. 1.6 mil of scale also gives a 12% reduction in heat output. So removing hardness from the water is vital to maintain energy efficiency and reduce blockages. Salt regenerative softening is a way that we can remove this hardness, but salts used within that process increase conductivity, leading to electrochemical corrosion problems I mentioned earlier. The solution again is to use pure demineralized water, as the demineralization process eliminates the hardness. Biofilms can also cause deposits. Sludgy, slimy colonies of bacteria grow even in oxygen depleted environments, and these clog everything up. They can be a real problem in low heat systems, which are a perfect temperature for the bacteria to thrive in. But again, do we really want to use biocide and expensive killer chemicals to deal with that issue? So I wanted to talk about these killer chemicals. The next time you use a water treatment chemical, please pay attention to what's on the bottle. These warnings up here are all taken from chemicals that your company may be using. How happy are you to use them? Is it okay to ask your staff to handle these? And how about drinking them? Would you? I'm betting you wouldn't. But would you drink pure water? Water that's purified exactly using the same process we use to bottle our office drinking water systems? I'm sure you would. And that's exactly what our demineralized systems produce. So let's talk about these killer chemical risks. Did you know there's a legal requirement to dispose of chemicals safely? Or you can risk 12 months in jail and an unlimited fine. If we explore a couple of scenarios quickly, let's say you repair a system that's filled with biocide and you need to drain it down. I mentioned earlier an 80,000 litre system before. How do you transport 80 metres cubed of biocide to a suitable facility? Who's going to transport it? Where even is that facility? And how much is it going to cost you? If you don't know that and you currently drain systems down, ask a question: where is that biocide going? Are you putting your staff, your contacts, and the environment at risk? Secondly, another scenario where you have biocide-infused heating loop transferring heat to another circuit. What happens if that heat exchanger is damaged or degrades over time? Is there a chance that biocide could leak across that barrier? How long before you notice? Has somebody been bathing in biocide? Could they have drunk it through a mixer tap? Best not to find out whether liability would rest on that one, and you can eliminate those risks by simply using pure water that you're happy enough to drink from to start with. It's got to be better than using chemicals, and it's not just good news for your staff, customers, and the world. It's also good for your pocket. Our products can fill systems for as little as 2p a litre, and if you compare that to the cost of those chemicals at 30p a litre, there are a lot of savings that can be made. So our products, we have two types of systems to demineralize water to VDI 2035 specification. This is our Aquatherm. It's used for smaller systems or to top up larger systems and maintain their pressure, useful to help keeping oxygen out of a leaky system. These products are designed to be left in place. It's compatible with BSE N1717, so it can be fitted as a permanent filling loop. And you can see from these pictures, it's insulated to protect it from damage and also from condensation. The filling block has a pressure reducing valve and a pressure gauge to maintain desired pressure, as well as a BA valve. And this is a double protection against any backflow, which is directed to a ton dish. If you like, for added security, there's also a triple ball valve configuration, enabling you to manually isolate the water at multiple points. This system's controlled by an easy to use interface. It's monitored digitally and all designed to be easy to use. Just set the parameters correctly and it's pretty foolproof. A replaceable cartridge that you can see there is light bulb simple to fit, just using a simple screw in, screw out action. There isn't even a need to turn the water off as it automatically seals itself. You'll typically get around 700 litres of totally demineralized water through each cartridges. Price-wise, you're looking at about 18p a litre. As with all these cartridges, everything from BWT, we encourage you to return them to us for recycling, which we do here in the UK. Our second product I wanted to just quickly talk to you about is our Aquatherm Move Power on the next slide. It's a high capacity system and it's much larger, but it's designed to be portable and compact, easily allowing you to transport it wherever it is needed. As you might likely have to go up and down some stairs, a nice feature here is that it comes complete with stair climbing wheels. It's also powder coated and fully framed, so it's built for a hard life. Again, it's got a digital interface. It can be controlled by Bluetooth on your phone, which allows you to see all the parameters that you need, including water quality readout, memory function, allowing you to store and recall the parameters of the job easily for future reference. Perhaps the most useful setting on this machine is that you can set it up to run automatically and shut itself off once a desired pressure is reached. So you can go out for lunch or leave it filling overnight if you've got a really big job. The cartridges within this Move Power will produce around 80,000 litres of water before they need replacing. So plenty for a big job or a really huge number of small jobs. Of course, there are ancillaries available, and we recommend that you use this system in conjunction with the Aquatherm on the previous slide to enable easy filling later, easy top up using the consumable cartridge when it's ready or time for servicing. Cost-wise, you're looking from about 7 pence to as low as 2 pence per litre once you've bought this equipment.
Super. I'm just conscious we need to wrap up because you're 10 minutes.
Next slide, and I'm done. So there you go. If you'd like to reduce plastic waste, use recyclable cartridges, save filling time, money, reduce chemical usage, protect against prosecution, and help the environment. Help us, please, in changing the world. Please remember that with us, our service comes first. We're always on hand for our products, help you specify and deliver them. Even if you just want some information, reach out to us, please. It's always good to get to know you, whatever your next job might be. Thank you. That's me done, Simon.
No, brilliant. Thanks very much indeed, Chris, for trying to keep the time. That was perfect. Thanks very much. A really interesting presentation. So I think there's already an intriguing question in the question sessions for you. We'll leave you to pick up. So
have a little look. Thank you.
Have a look, answer offline. So if I leave you to exit the stage, Tom, if you can pull Chris's slides down, and Marcel Sousa from ENWA, could we please ask you to come on the stage, Marcel? That's very good. Thanks very much.
I am here. Can everybody hear me and see me?
Yep, we can hear you and see you. That's perfect. I will leave you to make your presentation about the ENWA-matic. Thanks very much indeed, Marcel.
Fantastic. Well, thanks very much for giving us the opportunity to present. And really, what I want to talk about is the importance of effective filtration water treatment for heating and cooling systems. BWT and other companies have just presented, and really there are some similarities in my presentation also. But let us first ask the question, why is water treatment important? Well, there are a diverse range of systems and applications. So getting water treatment and filtration right is important for the smooth delivery of a successful project and the efficient operation of systems, as well as to prevent failures and costly repairs and disputes, as well as time and money. So design efficiency affects the productivity and profitability. And non-performance, such as lack of heating or lack of cooling, affects end users in different ways. So as an example, in hotels, that could lead to poor guest experience, increased complaints, temporary closure in worst case scenarios for repairs. In hospitals, temperature controls are critical to maintain ideal temperatures for patient care, and in operating theatres. Data centers that hold military, banking, government information also require that the cooling of those systems are effective, and instead of mechanical failures in those systems are the biggest generators of failures. And then we look at schools and higher education. Lack of effective heating would lead to poor learning environment. So, these are just some of the reasons, as well as the fact that manufacturers' warranties can be affected if you fail to keep water treatment within the manufacturer's recommendations. So let's go on to the next slide, if I can do that. So in terms of water quality considerations, there are 4 main causative factors, and these are all interlinked because water reacts chemically, physically, biologically, and these interactions occur simultaneously. So the main 4 causes of failures are corrosion, scale, suspended solids, and bacteria. And these are all interlinked, as is shown there on the bottom right-hand corner of your picture. So it's important that we have a holistic approach that can be easily and successfully managed. Because, as you'll see later in the topic, for example, of bacteria, both corrosion and nutrients such as suspended solids can actually help the bacteria to survive in systems. So these are the four main causative factors. Let's look at corrosion now. So corrosion impacts on components, their operation and efficiency. So corrosion inhibition right at the start of a system and during the operation is essential. And the direct impact of corrosion is the loss of metals and leaks, structure integrity, the seizing of components such as valves, pumps and seals, and also leads to the reduction in heat transfer efficiency. So research suggests that just a 2 millimeter layer of corrosion actually reduces the heat transfer efficiency by as much as 5%. And the indirect impact of corrosion is particle generation, and these particles begin to clog up heat transfer surfaces and components. So passivation is key, and the conventional way of passivating surfaces is to use corrosion inhibitor chemicals during the startup of a system, filling stage, and then to dose as required throughout the operational life of those systems. So corrosion inhibition is done in reference to BISRIA guidelines. So there are considerations that need to be looked at from environmental safety point of view. The last presenter, Chris, talked about some of those important safety factors of chemicals being used in systems. And we need to look at reliance on maintenance too. And of course, if we're looking at retrofitting technologies into existing systems, what we want to do is to bring those systems back towards their original design efficiency and minimize any invasive and potential impact on components. So again, the strategy that we're employing. Just a millimeter layer of scale reduces heat transfer efficiency by as much as 10%. So there needs to be consideration on the initial fill water and the makeup water. So whether that would be demineralized or softened water, depending on the type of systems that you're dealing with and the equipment that is being installed. Some manufacturers will require the compliance of VDI 2035, whilst others don't. So the direct impact of scaling is obviously scaling on hot surfaces, and it also impacts on components such as pump seals and O-rings, which some of the first components to experience problems. The indirect cause of scaling is the large particle generation, which again begins to clog up surfaces and heat transfer components such as plate heat exchangers. And there you see on the screen a picture, for example, of a cast iron boiler section where insulation effect cause hot spots and failures, eventually leading to leaks and excessive top up also. So it's important to have that strategy also, which will advise on what the initial fill water should be. And in the case of bacteria, bacteria can almost on all systems. This is the nature of microorganisms. And given the right conditions, they can survive and thrive. So without adequate filtration and water treatment, biofilm begins to form when bacteria adhere to surfaces in water environments and begin to excrete substance that can attach themselves to a variety of materials, including metals and plastics. So As biofilm grows in the systems, they become nutrients for bacteria, which helps them develop and progressively become more difficult to control. The impact on the system is an insulating layer, which can be greater than scale, causes blockages, and can cause microbiologically influenced corrosion, gas production, and the local deterioration of the pipework. So when we think bacteria control, we'll never be able to get rid of bacteria. But what we can do is create a harsh environment where bacteria cannot survive. And that includes filtration to higher levels, so you remove those nutrients, and also an elevation of the pH, because bacteria cannot survive in high alkaline environments. So it's about having this also specialists working together, would be energy managers, maintenance managers, and water treatment specialists, in order to design the right solution for a system, both on startup and commission and on operation. Now, suspended solids can be made up of components that are left from the construction phase. It could be corrosion byproducts, scale, and biological fouling. So it's important that high-level filtration is considered. The higher the filtration level, the better the heat transfer efficiencies. And over the last few years, we've seen the introduction in buildings of temperature control systems that have very small apertures. And so even smaller particles can begin to clog up these components, as well as sensors in systems, which then means that those temperature controls are not going to be as effective. Now, our technology is the ENWA, and this is an all-in-one side stream filter and water treatment unit, which eliminates the need to have to dose conventional corrosion inhibitor chemicals. It provides pH elevation to a range of 9 to 10.5, which is suitable for steel and cast iron components. And the full treatment unit is not suitable for systems that contain aluminium, but that can be used as a filter-only unit in those instances. So it relies on filter media materials, which are inside the unit, and as well as providing corrosion inhibition, it also helps to reduce the hardness of the water in systems, and filters down to typical levels of less than 5 microns. So that high level filtration ensures that the systems are going to be free of suspended solids, which would normally block up substance heat transfer surfaces. And these are sort of typical results here that you can see in this picture. So components such as plate heated exchangers, heat interface units are all kept clean. And so it's important that you consider both installation of this equipment on the primary side, but also on secondary loops. On the right hand side, you see pictures of pictures here of fan core units and thermographic images showing how suspended solids and in systems.
Marcel, I think we're losing you slightly, and I think we've kind of come to the end of the 10 minutes. Are you okay to wrap up? Oh, Marcel, I think we've lost. Yeah, I think
experiencing some issues with the upload afterwards.
Yeah, no worries. But thanks very much indeed, Marcel. We'll have to draw it to a close there because we've run over by a couple of minutes, and we've got to be fair to all the speakers. But it was a really interesting presentation, and thanks very much indeed for making that this morning. It's much appreciated. So
thank you.
Thank you very much indeed. Well, so Tom, could you please bring Simon's Douthwaite's slides onto the screen, and we'll ask Simon to make his presentation. So Simon is wrapping up the water treatment section this morning. So Simon, if we can try and keep the time, it's 10:35. You've got 10 minutes. And then wrapping it up, hopefully putting a bit of a wrap around the whole thing, talking about the VDI 2035, which is what lots of speakers have mentioned this morning. So Simon, do you want to kick off, and I'll just confirm I can hear you okay?
Yeah, good morning, everyone. So yeah, basically we're just going to do an overview of VDI 2035, the environment, its benefits for operators and end users. So who we are and our commitment towards a greener future in the UK. So our warehouses and offices are located in Poole in Dorset. We are supported by our German partners who have a combined experience of over 50 years in the field of electrochemistry, ion exchange, resin and filtration. They also provide specialist guidance to the BDI and offer OEM solutions for many renowned HVAC manufacturers. Working directly with consultants, clients and contractors, facility managers and operators, we raise awareness on the environmental benefits of chemical-free water treatment and the impact of incorrect water treatment. We offer design, technical and training support, allowing installations to become chemical-free and compliant with EDI 2035. We provide high-quality equipment manufactured to exacting standards from Germany, and in the UK we support various steering committees as leading experts in the field of chemical-free water treatment, contributing towards the latest edition of the BG50 documentation, and we're currently assisting the BSI on a new standard for heat interface units. So what exactly is the VDI? So the VDI 2035 are guidelines set by the Association of German Engineers. It was established in 1856, and the VDI is the largest engineering association in Western Europe. It's an organisation with over 150,000 engineers and natural scientists and more than 12,000 honorary experts. The VDI 2035 guidelines focus specifically on water treatment from mixed metals sealed systems. Part 1 focuses on scale formation and waterside corrosion. The guidelines stipulates that if scale formation, so total hardness, electrical conductivity, oxygen ingress and pH of the system water is maintained to certain parameters, then chemical additives are not required. The VDI 2035 has been referenced in EN 12828, heating designs in buildings, designed for water-based heating systems, a standard which has been applicable to the whole of Europe since 2012. The VDI 2035 is a preferred method of water treatment for many of the world's leading manufacturers. Following a simple 1-2-3 process, corrosion control can be achieved without the need for chemicals, minimizing our impact on the environment, while providing a sustainable method of corrosion control which prolongs components' life while maintaining peak efficiencies. So the two tables on the left is what you'll find in the VDI. The top table is a reference total hardness depending on heat exchanger size and water volume within that system. And the bottom table indicates where your electrical conductivity and where your pH range should be. So what are the three key elements? So dissolved oxygen. So oxygen within the circulated water acts as a driving force for surface corrosion. Tap water consists of roughly 8 to 11 milligrams per litre of dissolved oxygen. Continued ingress can take place through excessive top-ups and diffusion through permeable components. So examples are seals, plastic pipes, membranes and hoses. Incorrect pressurization and expansion can also have an impact. Fluctuations in pressure can cause negative pressure, so that's an under pressure, making the system in effect breathe, where air vents and sealing joints can pull oxygen back into the circulation water. So if we look at low saline systems, we're looking to achieve at 0.1 milligram per litre, and saline systems look to achieve 0.02 milligrams per litre. So if we look at the pH of circulating water helps achieve passivation by the formation of natural oxide layers, where inhibitors create a false layer of protection and strip away these oxide layers. VDI 2035 requires a pH in the alkaline spectrum, so that's 8.2 to 10, depending on what your system metals are, as this contributes to the natural formation of strong oxide layer protection, protecting the metal surfaces from oxygen attacks. So low pH ranges result in acid attacks and corrosion regardless of oxygen entry. Electrical conductivity. Electrical conductivity of water is driven by its mineral content and salt content. The higher the value, the higher the risk of galvanic corrosion and possible scale formation. It has long been known that having a high level of conductivity creates an environment where corrosion is accelerated due to galvanic corrosion, which is caused by a transfer of electrons between different metals and the rate at which oxygen is consumed at the metal surface. So what is electrochemistry? So due to the differential potential between anode and cathode, spontaneous reactions take place inside the reaction chamber. The unknown metal serving as the anode donates electrons to the nobler metal serving as the cathode, and thereby dissolving itself as metal ion. Due to the spontaneous formation of the galvanic element, an electrolysis of the water without water decomposition takes place. So again, following the 1, 2, 3 principle, so dissolved oxygen, elemental dissolved oxygen, so that's not the part of the water molecule, is reduced at the cathode, resulting in the formation of hydroxy ions. Electrically induced oxygen reduction maintains low levels of dissolved oxygen content, reducing the risk of system corrosion. The pH. So due to the formation of magnesium hydroxide, these electrons pass into the solution. There is an increase of the pH. Free carbon dioxide and other acids are neutralized by the magnesium ions, which provide the ideal pH ranges for chemical-free water treatment. Electrical conductivity. So the formation of undissolved magnesium hydroxide can bind to elements such as calcium, as well as water, which contains dissolved metal ions. Metal separation can take place in the galvanic element under certain conditions, which reduces the concentration of the dissolved metals in the heating water and calcium concentration. Alongside the use of demineralized water, low saline operation can be achieved. The water that leaves the reaction tank has a lower amount of dissolved oxygen and a higher concentration of hydroxy ions, so we increase the pH value, than the circulating water. As soon as these two come into contact, they are mixed or diluted, resulting in a heating water with less amount of dissolved oxygen and higher alkaline pH. So what is the process? So again, we're following the 1, 2, 3 process. So install. So the initial system fill water should be preconditioned by a suitable mobile filling station, such as our EnviroFill units. The process removes minerals and salts, lowering the electrical conductivity, reducing the risk of corrosion and scale formation. The filling station should be used to ensure the pH of the fill water is not reduced to low levels, but ideally giving an increase at point of fill. So step 2 is clean. So once the system has been filled, vented and pressure tested, the system should then be run at flow velocities stated in visuals BG29, either retrieved via the system pumps or temporary pumps utilised to ensure required velocities are met. Temporary filters such as our FTK mobile filters should then be attached to flushing points on the system to filter out debris, grease, paste, construction residues, and any flash corrosion particles. So step 3 is protect. So during the initial CPC procedure, the elector tank should be allowed to operate, which will remove circulating debris, as well as remove dissolved oxygen and regulate the pH to the desired levels. Inspections of the elector tank and refill devices can now be included within routine maintenance of the plant room equipment. So the anode should be replaced every 2 to 5 years. Electrochemistry constantly operates to remove dissolved oxygen and maintain optimal pH ranges within the circulating water. In many cases, no additional degassers or air or DARE separators are required. So what we find is closed loop pre-commissioning lends itself perfectly to filling VDI, to filling systems to VDI 2035 low saline requirements. The CPC process has many benefits over traditional balanced flush, where millions of litres are wasted with chemically treated water entering our drainage systems. So what are the benefits for the environment, designers, system operators and end users? So the process works based on natural science, and corrosion protection is sustainable, is environmentally focused with no need for traditional harsh chemicals such as acids, biocides or inhibitors. So we're not handling, storage or disposal of chemicals, so minimal health and safety, no cost reports. By removing the root cause, it prevents corrosion from occurring, not just inhibiting, unlike chemical-based treatment. So we prevent large amounts of precious water being contaminated and dumped to our drain, as in the case with traditional chemical cleaning and balanced flushing. Proven time-saving techniques over traditional flushing, financial outlay and time spent on site. So we simplify system installs and reduce costs, as multiple system components can be replaced by one elector reaction tank. We provide long-term reliable corrosion protection to maintain plant equipment, reduce breakdowns whilst maintaining operational life, performance and efficiency. Electrochemistry equipment is simple to maintain and inspect, eliminates the need for costly ongoing chemical monitoring treatments by specialists. So our model is no chemical cocktails, simple 100% natural chemistry. If anybody's got any questions, please put them in the chat or contact me directly.
Brilliant. No, thank you very much indeed for bringing the section on water treatment to a close, and exactly to time as well, Simon. So you get a gold star for that one. Thank you very much indeed.
Good try. Thank you very much. Thanks everyone for your time.
No, thanks very much. A really informative presentation. Thank you very much indeed, Simon. Much appreciated. So we'll ask Simon to step off the stage, and we will now start our second section. So our second section is about technology solutions for heat networks. And the first speakers this morning is a double act. It's Neil Parry and Stephen Hart from Armstrong Fluid Technologies. And they'll be briefly running us through pre-packaged plant rooms, but with a particular focus on with waste heat recovery as well, as I understand it. So waste heat utilisation. So over to Neil and Stephen. Thanks very much, guys.
Thank you, Simon. Can everyone hear me?
Perfect. Lovely. Thanks, Neil.
Great.
Morning all. I'll let Neil start.
Firstly, I'd like to thank the UKDEA for the opportunity to present today. As a winner of the Queen's Award for Enterprise in Sustainable Development, Armstrong have always viewed district energy as a key focus area. District energy is a market that Armstrong have been involved in for a number of years. However, as the effects of climate change are becoming more and more visible and the need to rapidly reduce carbon emissions intensifies, Armstrong has made district energy a key vertical market and resourced accordingly. Historically, the HVAC industry has always looked for the silver bullet in the plant room. Is it CHP? Is it solar? Or perhaps heat pumps? The reality is that there is no silver bullet with regards to energy sources. What's right for one project may not be right for the next. However, if there is a silver bullet, then it's surely the heating and cooling networks themselves. District energy is a proven technology for reduction. Energy networks, both heating and cooling, are the facilitator for the integration of renewable energy, the utilization of waste heat, and the pathway to sector coupling. Studies have shown that the fastest and most cost-effective way for the wholesale reduction of the carbon emissions associated with heating, cooling, and domestic hot water generation in buildings is via the proliferation of district cooling and heating networks. These studies also show that a hard electrification approach will be more costly and actually delay our arrival at net zero. So today I want to look at the utilization of waste heat. Every day, a huge amount of energy is utilized in various industries, processes, and in manufacturing. Every day in these industries, terabytes of heat energy are wasted to atmosphere. The first law of thermodynamics states that energy cannot be created nor destroyed. It is simply transferred from one place to another. Wasting this valuable resource by letting it drift to atmosphere must be addressed. We need to capture it and use it. Energy is the ability to do work, and in our context, the work is the heating, cooling, and hot water generation within a building. The utilization, of this waste energy should therefore be our focus. Energy needs to be transferred between buildings, between processes, between commercial and domestic buildings. This is sector coupling, and again, we find that district heating and cooling are the enablers or the facilitators for sector coupling. Without district energy, sector coupling cannot work. So what exactly is it? Sector coupling revolves around four energy systems: district heating, district cooling, electricity, and gas. And the gas can be natural gas, biogas, hydrogen, etc. Outside of these four systems, we have the sources, the storage, the conversion, and the use. Looking at the schematic on the right, let's take wind, for example. One of the negatives of wind is that sometimes we have it and sometimes we don't. Sometimes we have more than we need, sometimes we have less. When we have an excess, we can see that we can utilize that excess and store energy in the storage phase in, say, reservoirs for hydroelectric generation. The water can then be released, creating electricity via turbines at times of high demand and sent back into the electricity grid. Alternatively, if there's an excess of electricity, then this can be converted via a large-scale heat pump, for example, into heat energy and sent into district heating or cooling networks. The energy is then made available for the district heating and cooling end users. Looking at the end users, you can see that industries are listed. They can be consumed. They can be consumers of both electricity, heating, and cooling, but also prosumers, sending heat energy back into the district heating network. Looking at the larger graphic, we can see in a stylized way how this would look in real life. Energy is flowing in various forms between the different power grids. Multiple energy sources are all connected into these grids, and multiple technologies can be used to convert or capture energy. One example of this is the data center. This is another key vertical for Armstrong, and we supply pumps, packaged thermal transfer equipment, and plant rooms. The return temperature from the data center cooling is significant and can be utilized in the district heating network instead of sending it to atmosphere. As the heating and cooling networks expand and they come close to available waste heat sources, then those sources can be connected into the network via waste heat transfer stations. On this slide, the schematic on the left is from CIBSE's CP1 Code of Practice. You can see at point A, there are connections for a pre-cool circuit. At this point, this could be the location for a plate heat exchanger that could be capturing waste heat from wastewater, process, data centers, etc. Depending on the temperature captured, the two heat sources to the right of the thermal store may not be required. It is also entirely possible to remove some or all of the heat sources shown on the left-hand side of the thermal store, again, depending on the amount of energy that can be captured and the loads on the network. On the graphic on the right, we can see a schematic produced by a consultant that we're working with on a waste heat transfer station, taking waste heat from a data center. The cooling return is at 28 degrees C, and this is then utilized by the water source heat pump, raising the output temperature to 50 degrees C for the district network. The dry air cooler is utilized to balance the load differences between the data center output and the district energy demand. While the DAC may at times send some heat to atmosphere, it is important to note that a significant amount of waste heat will be utilized. Adding additional thermal storage on the district side could allow even greater energy capture from the data center. The rise of edge data centers that tend to be located closer to more densely populated areas are ideal for this type of energy capture. At this point, I'll hand over to my colleague, Stephen Hart, who will take you through the Armstrong products designed for this waste energy capture. Thank you.
Thanks, Neil. Neil, I'm just trying to advance the slides. There you go. So just on this graphic here, we're showing, we've got at Armstrong, we've got a couple of large factories here in the UK. One of our two factories is a 70,000 square foot facility in Droitwich, just south of Birmingham. And this is dedicated to the off-site manufacture of prefabricated pumping solutions and packaged plant rooms, particularly for the commercial HVAC, data center, and district energy vertical markets. The drawing and the renders that we see on screen right now are two examples of how we can deliver packaged solutions with integrated waste heat recovery capability. It's true, we've seen the growing potential of capturing waste heat from data centers. We participate in these two market verticals and been quite successful in delivering both data center cooling plant rooms and district energy centers manufactured off-site. And we've noted, particularly driven by the emergence of liquid immersion cooling, we're starting to see data centers being much more highly concentrated computing power, which is much more likely to be occurring in urban areas, where, of course, we're starting to see in the UK the grow out of city district heating networks. So where once upon a time, really imagining practically capturing rejected heat from data centers was really recognized as something that was only really possible in Scandinavia, where we had a high coincidence of heat networks and data centers. We're actually starting to see this being a realistic prospect occurring in the UK. So we're able to fabricate in a kind of engineered to order way. It means that the products can be both modular and scalable. And importantly, on the energy centers, these can scale up and be built out at the same rate at which the entire network builds out, making them easier to commission at the beginning and make them run more efficiently as we expand and extend. But the energy centers with the waste heat recovery in Droitwich facility, it's really where we apply our modern methods of construction. And so this photograph shows inside one of our packaged plant rooms, and this is off-site fabrication in accordance with the modern methods of construction, and that's really accepted as an industry to deliver a number of benefits. You get a very high factory assured quality. It's much easier to control our processes and production within a factory environment than on site. Certainly, there's a reduced installed cost. We can drop these things into place very quickly and very minimally with reduced commissioning and installation activity on time. Minimal disruption to site, reduced project risk, and of course, with reduced commissioning time on site, it means a lot of the factory assured and performance testing to make sure everything works together ahead of time can be done. So this, of course, ultimately leads to increased health and safety stats as the on-site manufacturing process is much more controlled and much reduced. I think with that, I do have a couple of points, but I noticed Simon pops up on the screen here, and it's normally a polite indication to conclude. So I shall do exactly that and just ask anybody if they want to hear more, or indeed if they want to come and visit our Droitwich facility. That they would all be very, very welcome. Come and actually see how we're applying what we're showing on the screen today.
Yeah, no, thanks very much, Steve and Neil. I thought it was really interesting, actually. I didn't realise that you were as far advanced in terms of packaged plant rooms with waste heat from data centres. So really interesting presentation. I'm sure many other people will be in contact with yourselves after the event. So big thanks to both of you for presenting what you have done today. So if I can ask you to leave the stage. Tom, if you can pull down the presentation. And I believe we've had a slight switch around. We're going to have Professor Carlos Ugalde from Cardiff University. They'll be talking about a state of charge estimation of thermal batteries for heating and cooling applications. So over to yourself, Carlos. Did you want to kick off? And I'll just confirm I can hear you okay?
Yes. Hello, everyone. Can you hear me?
Perfect. Lovely. Thanks very much.
Brilliant. Good morning, everyone. My name is Carlos Ugalde, and I'm an academic at Cardiff, and I'm very thankful for the UKDEA for the opportunity to talk to you this morning. So this presentation aims to introduce a methodology for the estimation of the state of charge of thermal batteries, both for heating and cooling applications. And I would just like to highlight that this innovation work was conducted alongside Dr. Hector Bastida, who is in the room as well. So thermal energy storage, as we know, is a technology which is capable of storing thermal energy, which can be used at a later stage when required. This is achieved by modifying the enthalpy of the storage medium. Making an analogy with electricity networks, a thermal energy storage unit acts essentially as a thermal battery. These type of batteries are commonly used in a wide range of heating and cooling systems. For instance, a hot water tank is widely used in households, while in a district cooling system, such as the one that is shown at the bottom of the slide, ice tanks may be adopted. Thermal stores are useful as they act as a buffer between supply and demand. They can also provide flexibility, which enables peak demand to be shaped, perhaps loads to be shifted, and electricity costs to be reduced. The concept is illustrated by the diagram at the top of the slide. The battery is charged during periods of low demand. However, there's a high thermal demand, the battery is discharged. Among the type of thermal batteries, those relying on sensible heat are the simplest, where the temperature of the storage medium is raised or lowered. However, in latent heat batteries, the phase of the storage medium is changed at nearly constant temperature. During the phase transition, the storage medium, which is called phase change material, or PCM for short, absorbs or releases a large amount of heat. This is called the latent heat value. This type of batteries, based on latent heat, have a high energy density and may be preferred over sensible heat. However, for them to be very effective, a suitable charging and discharging process needs to be enabled by the accurate estimation of the battery's state of charge. The main problem here is that a reliable and direct state of charge estimation requires incorporating internal sensors so as to monitor the temperature gradient of the PCM. This can lead in turn to high instrumentation costs and technical specifications. This slide illustrates the use of thermal batteries in district networks. For example, at the left-hand side, I have a figure which shows a simplified schematic of a district heating and district cooling networks. What I would like to highlight in this slide is the inclusion of hot and cold stores in the network. At the right-hand side, we can see photos of different thermal batteries. The top right photo shows 3 ice storage tanks of different dimensions. The interesting thing that happens is inside. The tank will be filled with liquid water, but there is an arrangement of spiral tubes made of polyethylene, where a heat transfer fluid, in this case a refrigerant, is going to be circulated. Now, if the temperature of this refrigerant is below 0 degrees, ice is going to be growth. If a warm heat transfer fluid is then circulated, the ice will melt. When water is changing phase, heat is either released or absorbed, which for a cold store implies that the battery is charged or discharged, respectively. Now, at the bottom of the slide, we have an internal arrangement of a thermal battery for heating. The principle, though, is the same. An arrangement of tubes is submerged in a PCM and heat transfer fluid circulates inside the tubes. The pictures are shown and they are relevant because understanding the internal configuration and geometry of the battery is very important to enable the state of charge estimation. So how do we achieve this? So let me walk very quickly through the methodology. The first step involves obtaining a dynamic model of the thermal battery. This process is summarized by the block diagram at the bottom left of the slide. This is not a computational fluid dynamics model, but instead a simple one dynamic representation. The modeling requires an internal description of the shape of the channels where the heat transfer the heat transfer fluid circulates, and other attributes such as the heat transfer area. It is also necessary to have knowledge of the thermophysical properties of the heat transfer fluid and the PCM so that we can calculate the heat transfer process accurately. This way, we can also obtain the heat transfer coefficient and we can establish energy balance so that we describe the thermal battery behavior. To reproduce the heat transfer process in a more accurate manner, though, we use a discretization approach. Here, the tubes carrying the heat transfer fluid are divided into nodes. This is illustrated in the top diagram at the left-hand side. This discretization process enables the definition of control volumes, and this captures how the heat through the tubes varies due to temperature changes of the heat transfer fluid and the PCM. The second step is the design of the state estimator or state observer. This is a concept basically borrowed from control engineering, which enables the estimation of the internal batteries inside the thermal battery without the use of internal sensors. The block diagram of the observer is at the right-hand side, but what I would like to highlight here is that for this observer to work, only 3 measurements are required. These are for the heat transfer fluid, either the mass flow rate, the input and output temperatures. And since we don't need any internal sensors, the instrumentation costs are significantly reduced. The final step in the state of charge estimation methodology is effectively the calculation, which requires first to obtain a specific heat against temperature curve of the PCM. However, this may be directly provided by a manufacturer. If this curve is integrated in time against a defined range of temperatures, the latent heat value is obtained. This is nothing else than obtaining the area below a curve. The value of latent heat value is employed to calculate the state of charge, as this is the energy per unit of mass that produces the phase change. So for a hypothetical PCM with a melting temperature of 20 degrees, the graphs at the right-hand side show the state of charge for 3 different temperatures. For example, what these graphs are telling us is that at 19 degrees, the state of charge would be nearly 16%, which is shown at the bottom graph. Whereas for 21 degrees, this would be around 84%, which is shown at the middle graph. Whereas for 24 degrees, this fictional battery would be fully charged, which is shown at the top graph. To further reduce computational burden, instead of conducting a numerical integration of the specific heat against temperature curve, we define a lookup table. This is illustrated in the block diagrams. Now, we have to remember that since we have been using a discretization approach, the state of charge calculation should be conducted for each of the nodes. This is shown by the diagram at the middle of the slide, at the bottom. Therefore, the total state of charge is calculated simply by obtaining the average value for all of the nodes that have been defined. To demonstrate the verification, to verify the state of charge estimation method, simulations have been conducted for which a real thermal store of a heating application was adopted. This is a shell and tube unit with the shell filled with a high-density polyethylene PCM. Inside the tubes, a synthetic organic heat transfer fluid circulates. The thermal battery was modeled using a discretization approach. The observer was designed using the model of the battery and the state of charge calculated as discussed in the previous slide. So a schematic is provided at the right-hand side for this thermal battery. Simulation results were compared against experimental data, which has been available and taken from published references. This data basically consists of the input and output temperatures of the heat transfer fluid and the state of charge. The simulation considers a sequence of charging and discharging processes. The heat transfer fluid in this case has a constant value of mass flow rate of 1.09 kilograms per second, just to simplify things. When looking at the results, the top graph shows the input temperature of the heat transfer fluid with a red trace. The output temperature in turn is given with a blue trace. This, I would like to highlight, is experimental data. If this input profile is fed into the model, it can be seen that the simulated output temperature, which in the graph is given with a black trace, is similar to the real one. This demonstrates the accuracy of the thermal battery model. However, more importantly, the temperature estimated by the observer, given with a dashed line, matches very well with the output of the simulation. The bottom graph shows the performance of the observer, where we can see the estimated temperatures. This is provided by the observer without the need for internal sensors. Now, the final graph at the right-hand side provides, with a black trace, the energy provided by the latent heat obtained through simulation. This is basically the state of charge calculation, which is given in percentage. I would like to highlight that this value matches very well with the experimental data given with a dashed red trace. So just to sum up, we know that thermal batteries can play a critical role in decarbonizing heat, and we need to manage them effectively so that we can provide flexibility. To support this process, an innovative methodology for estimating the state of charge of a latent heat battery has been presented. The approach works reasonably well and has a number of advantages that I'm highlighting with the bullet points in the slide. This is a basic approach using a simplified mathematical model. There is no need for costly sensors to be included. We only need three measurements, and due to the adoption of a lookup table, computational burden is reduced. So that is all from me. Thank you very much.
Thank you very much indeed, Carlos. That was a very interesting presentation and a lot of food for thought. So thanks very much indeed. I'll ask you to leave the stage, and Tom, if you don't mind putting Carlos's slides down and putting Krista's up. So Krista's joining us from SWEP, and he will be talking to us about the new Hypertwain. Is that the right way of saying it?
That is absolutely right. Do you hear me well?
I can hear you perfectly, so I will leave you to make your presentation. Thanks very much indeed.
Thank you. My name is Frennfelt. I'm business development for SWEP, a plate heat exchanger manufacturer. I will just take one slide about our company. We are specialized in braze plate heat exchanger. We are a manufacturer, global manufacturer. We are nearly 40 years old, so we have an anniversary next year. About 1,000 people. Oh, it goes back. Here we go. About 1,000 people, and we are delivering about 4 million units per year. I will talk about our new plates for heat pumps, our actually largest market segment. But before that, maybe fresh you up your mind what is actually a ref cycle and how it works. We have 4 main components: a compressor, compressing the air, the gas is going into a condenser where it will be condensed, and then an expansion valve and into the evaporator where you are cooling the liquid. And if we zoom in on the details, we can start with the condenser up in the right corner. There is gas coming in, cool down, and a condensing stage where the heat transfer is taking place, and in the end you have a subcooling of the liquid when it comes out for the expansion valve. If you look at the down left corner, you can see the evaporator. It comes in as a mixture of gas or liquid or pure liquid. It's evaporate, changing phase, and finally it's a superheated vapor coming out of the heat exchanger. And the reason why I mentioned this is a part of the Hypertwain development. The ref cycle is, or the heat pump cycle, an evaporator and then the condenser. And what you see on the right upper graph, that is the conventional DX, direct expansion evaporator, to make sure you have the superheating of the gas. But you can put that heat exchanger in the middle. It's a suction gas liquid heat exchanger that improves the efficiency and allow you to run the evaporator in co-current. And then you get the graph on the right hand below, where you can see that the temperature, temperature approach, it's much more closer, and it makes it more efficient. So if you focus on that small heat exchanger in the middle, when I change to the next slide, because here is the whole point with the Hypertwain plate, where you have this superheater, liquid cooler, whatever you would like to call it, integrated in the plate, which allows you to add much larger surface for evaporation to compare to a conventional where you have 70% evaporation and 30% of the heat transfer area is superheating. The hypertwain allows you to have a much more evaporation area and evaporation temperature much more efficient, and the superheating. And how does this work in the system? We have here a schematical ground source heat pump where you have an evaporator where you can see that if you follow the yellow line where the subcooled liquid is coming out from the condenser going into the evaporator and will be subcooled by heating up the gas before it goes into the compressor. And you can run it, and this is the point, you can run it in the reverse mode where you have the cooling, and then the evaporator turns into a condenser and the condenser turns into an evaporator. So it's 100% reversible. Normally conventional heat pump is optimized for either cooling or heating, but with the hypertwain plate you can actually run it in reverse mode. And if I'm going to give you some figures, the CUP, coefficient of performance, will improve about 10 to 20%. The EER, energy efficiency ratio, over the seasonal, it's improving about 5%, and that is reducing the electricity consumption and the cost of operation. So the yearly saving is quite considerably. And in the last slide, I was actually having a video. It's not possible to show here, but you can live stream it from our website to see the flow principle of evaporator, and then it suddenly turns into a condenser. And then you can see the arrows in and out and how it works if you have possible to do that. So that's all. Thank you very much, the hypertwain plate.
Thanks very much indeed, Krista. Very, very interesting. And as you finished so early, I'll ask you one question which is burning in my brain. So, people wouldn't normally configure heat pumps themselves. They'll buy presumably a packaged heat pump. Are there particular manufacturers who are starting to embrace your hypertwain?
Yeah, we have one manufacturer started to test it out, but it takes some time to redesign the skid, so to say. So it's coming more and more.
Okay, and how would they find out which manufacturers are using your particular technology? Would that be best to speak to yourself, Krista?
Yeah, I don't have the name here right now, but they have found it very efficient so far, yes.
Very good, very good. Okay, well, I suggest that any delegates who are interested, please keep in touch with Krista. Sounds like a very interesting innovation. Thanks very much indeed. So, Krista, thanks very much. I'll ask you to step off the stage. Very interesting. And Tom, if you don't mind putting Krista's slides down. So dovetailing neatly from heat exchangers to improve efficiency of heat pumps through to Ken Hoffmann from GEA, who'll be talking about high temperature heat pumps. So Ken, hopefully you're there waiting patiently in the green room, and you can come onto the stage now to make your presentation about high temperature heat pumps. And just while we're waiting for Ken, we're nearly running back to time. We're about 15 minutes behind. So thanks very much indeed for all of you who've waited patiently with us and have stayed connected this morning. We've got a really excellent turnout. So I'll just see whether Ken's joining. Excellent. There we go. So if you want to just start speaking, I'll just check your audio is okay.
Yes. Can you hear me?
Perfect. I will leave you in peace and let you get on with your presentation. Thanks very much indeed.
Okay, good. So I'm here to present our heat pump solutions from GEA. I'm myself been working for GEA for 9 years now, and let's just see. Can we change the slide? Did it? Yeah. All right, yeah, let's go. So first of all, we have introduced this new range of standardized heat pumps, because we have seen for district heating that the demand is growing exponentially. So to try and get out there and have some standardized solution which improves efficiency and it lowers the delivery time. We have to develop this range of heat pumps that can go from low temperatures, so ground source, air source, whatever, and delivering up to 95 degrees as the hot water outlet. We have a range of different models going from 700 kilowatt up to 3 megawatt. We have a very unique design of heat exchangers. We just talked about heat exchangers, but to have a low ammonia charge. This is a solution we have patented and developed ourselves to have a minimum ammonia charge in the system, because we want to deliver a safe system. And that is, of course, ammonia is smelly, and so you want to have as little as possible. But at least it's not an F-gas, because there is increasing focus on the damages caused by the synthetic gases when they are getting into the nature after and break down into the nature. I think we all are aware the frying pans we are buying are now PFA free. See that
We seem to have lost Ken just for a second, so hopefully he'll be back in the room for in just a moment. I'll flick on to his next slide so we can see what he was planning to say. I'll just stay online until we've got Ken back in the room. So again, thanks very much to all delegates for attending this morning. Much appreciated. Big thank you to all those speakers. There are some questions going into the question section. Ken, we've got you back, which is excellent news. Just to explain, if you hover over the slides on the right-hand side, there's a little arrow, and if you just press the little arrow with your mouse, you can move forward.
I don't think I was entered correctly first, because I didn't have the arrow. So, but I'm back. As I said, we have this heat exchanger where it has a very low ammonia charge, but of course it's not one solution fits all, and that's what we have learned from the district heating projects we have been doing, that it very much depends on the heat source we have for these projects, and that's vary a lot from data centers, it's process cooling, ground source. We also have some deep geothermal heat pumps installed, not in UK, but in Europe, where you have warmer water. But the bit about ground source is that it's not always completely clean. There is some particles in it, and you want to make sure that the particles don't get stuck in your heat exchangers. And there is different ways to solve this, filtration, backflush and so on, which I will get back to. But another solution is also, if there is increased fouling of the water, is shell and tube or falling film, which you don't have the build-up of material in the heat exchanger. You are able to clean the heat exchangers while in process. So we do all these specialized solutions also to optimize the efficiency of the heat pump solution. And finally, of course, there is air, where you need a completely different heat exchanger to extract the heat out of the air. But of course, you see you are increasing the ammonia charge when you change the solution of the evaporator type. Regarding filtration, there's already been a couple of very interesting presentations regarding how to make sure that the heat exchangers stay clean. And that's also what we see from the project that we are involved in, that there needs to be focus on making sure that the heat exchangers do not foul up, because it's not always you have clean source water. So something like a backflush filter, which, where you can flush it whenever it starts increasing the pressure drop over the filter, so you don't need to take the filter apart, but it can be cleaned while in operation. Another thing we have seen or have done is to have reverse flow. So that's in particular where you have like snails and stuff like that travel into the heat exchanger, and it takes a while for them to get stuck onto the plates in the heat exchanger. So if you reverse the flow, every 24 hours or something like that, you are able to flush them out before they get stuck onto the heat exchanger. So that helps extending the time between you need to clean them, because you will need from time to time to SIP clean heat exchangers if it is if there is organic material in your water source. So that can be citric acid that you can be using, which will take out any organic material that is on the heat exchanger. So filtration and the SIP cleaning of the heat exchanger, make sure that you have a good heat transfer of the heat exchanger throughout the life. The fourth option is the bowl cleaning system, where you have a shell and tube. Then you can have these small rubber bowls being flushed through the tubes while it is in operation. So if you have a heat pump system that you need to operate 24/7, this is the best solution, because while it is in operation, you send these rubber balls through the tubes, which are cleaning the tubes while you are still producing heat. So you don't interrupt the production of heat, which you will have to do if you are SIP cleaning a heat exchanger. Oh, no. I think we got too low. Fine. So, in the UK, we have three major projects for district heating we have installed. So the EleXion one, where we are taking the air out of the ventilation air. So this is almost the same as an air source, but to keep the ammonia charge low, because it is in central London, we are using an indirect system. So it's one of our standard heat pumps, but it has a water loop going to the coil, which taking the energy out of the air coming from the ventilation. This is supplying 80 degrees for the district heating. The same is the case for Gateshead up in Newcastle or near Newcastle, where we also supply 80 degrees. But in this case, we are taking the water from an disused mine that have filled up with water. So it's nice and warm. The mine water is now 15 degrees. So we cool it around 6 degrees and pump it back down a separate place in the mine. So the cold water is not going to go back into the heat pump loop. There is a good view of how the water is distributed within the mines. So where we are pumping the water back down into the mine is not recirculating back to the water we're using for the heat pump. So this is in total 6 megawatt, 2 times 3 megawatt heat pumps installed there. We also have actually 3 heat pump installed at Swaffham Prior, 2 ground source and 1 air source. This is to optimize the system. So when it's cold in the winter, they can mainly use the ground source heat pump, and in the summer, where you have warm air, they can predominantly use the air source heat pump. By having this mix and match, they're able to always have the highest efficiency of their heating network. I have a few pictures here. This is, as you can see from Gateshead. This is the 2 times 3 megawatt. It's a total of 4 compressors, because it's a 2-stage system, because we need to lift the temperature all the way down from around 7 degrees as the water cooled down to, and we need to heat the water at up to 80 degrees. On the right side, you can see the plate and frame heat exchanger. As said, sometimes we need these special solution, and the plate and frame is in this case used because if there is some material in the ground source water which is not caught by the filter and gets stuck in the heat exchanger, we are able to open the heat exchanger and mechanically clean it and get it back up running again. And the final slide, almost final slide, is the SWEP one, where you can see we have these air coolers outside. At this picture, so we only installed one, but all 3 heat pumps are now up and running. Of course, you need a bigger ammonia charge, because you have the ammonia directly in the coil in this case. But again, you see in general, it's the standard design on the heating side with the low charge plate and shell heat exchangers. So that is all I had for this session here. But if you're interested in any of the things I spoke about, you're always welcome to contact me or go onto our website and have a look at what else we have to offer.
Yeah, no, thanks very much indeed. Very interesting presentation, and very interesting that those schemes have literally just gone live in the last month. So some interesting news for people, and something for people to talk to you about in terms of seeing the practical application of high temperature heat pumps, which is really very good. So thanks very much indeed, Ken. Much appreciated.
Thank you.
Okay, we'll leave Ken to leave the stage. His contact information there is if you'd like to speak to him after the event, and if we can pull Ken's slides down, and if you've got a question for Ken, please put it in the question session. And we'll now draw this second section to a close. I'm going to invite Glenn Harrison to join the stage, and Glenn will be talking about their innovative V-Therm HRU heating, hot water and cooling HRU. So Glenn, do you just want to kick off? Check I can hear you okay?
Thank you, Simon. Yes, I can hear you. Can you hear me?
Perfect. No worries. I'll leave you to it. Thanks very much.
It's a bit like Eurovision, isn't it? Okay. Well, thank you very much. I've been invited today to talk to you about Vital Energy's range of heat interface and cooling units. But I want to do that and apply a bit of context to the conversation. In essence, the UK carbon agenda is driving a move towards the electrification of heat. And what we're seeing is a move towards much lower temperature heat networks. So at Vital Energy, we spend a lot of time, we've got our own design capability here at Vital. So we design networks, we spend a lot of time designing the plant rooms, the distribution systems, and we get some fantastically efficient systems. There are more HRUs on a heat network than pretty much any other appliance, and it often gets forgotten. If the HRU doesn't deliver the performance that the low temperature system demands, essentially you're compromising the network overall efficiency. So at Vital, we've taken a slightly different view. So we've gone back to basics with our heat interface units and looked at how we can optimize those systems to operate at lower temperatures. So this means we've gone back to look at the plate designs. So we've looked at increasing the plate sizes, the flow rates that we get through our heating plates. We've also looked at the casing of the system as well to make sure that the heat losses are the best they possibly can be for the system. We also look at the internal pipework diameter and the HRU as well, again, to optimize the flow rate through the units to ensure that we're getting the best performance, the best efficiency out of the heat interface unit. So what we're trying to say is that, yes, low temperature systems are here to stay. And what we need to do is make sure that the HRUs that are connected to those low temperature networks are optimized and as efficient as they can be. It's all very well and good designing your HRU to be fully optimized for those temperatures, but we also need to have the ability to have some control mechanisms in place to make sure that systems are commissioned properly and that the ongoing lifetime operation is also as efficient and optimized as it is possible to get. So when we have a HRU that gets installed into a customer's property, the system is commissioned by Vital engineers using an app-based digital platform. Essentially what that does is ensures that through the entire commissioning phase of the HRU, the parameters that are set up at the point of design are input into that system. So it gives us that verification that the HRU is set up according to the design, and we're going to get the optimum benefit from it. Over time, the HRU communicates through a number of different mediums. So it has its own inbuilt communications module. That module communicates over MBIOT, MBus, Ethernet, GSM. So a number of ways to get the data out of the assets. And it's access to that data that is absolutely critical in understanding whether the machine is delivering what we expect it to do. That also gives us the ability to understand how the unit works in practice, so how the network design as a whole is performing. But we also have the ability to engage and understand how customers are using and interacting with the system. So we do that through our Glass digital platform. Another thing that our marketing team are very, very keen for me to mention is that the HRUs are now manufactured in Blackburn. So everything's made in the UK. So we assemble some components, but we also have our own fabrication department as well, manufacturing in the UK. So we're actually bringing this range of products and more jobs to the northwest of England. So the digitalization of heat networks has been a topic that we've discussed many times before. What digitalization allows us to do, so once we get access to that data, it allows us to understand network performance, to see what parameters we're getting out of the machines in operation. It allows us to remotely fix any machines that may be performing outside outside of those parameters. So it gives us that ability to make sure the systems are continuously optimized and that heat network will always deliver against its design and financial targets. But more than just network operation, the digital platform also gives us access to the consumer. So it gives us access to see how the consumers are engaging with the systems, how they're using their heat network, how they're using the heat interface unit, how they're using their heating system, and how they're managing with the payments and the tariffs that have been set up on that network as well. So customers, we've brought the capability to customers of Hive, Nest, and Tardor, other applications in the UK market becoming very prevalent in terms of how you control your heating system remotely. We've also brought that to the range of heat interface and cooling units. So that means the customers have the ability to set schedules, interact with the system, turn it off remotely, turn it on remotely, and do all those things you can do with the Google, or the Nest and the Hive type applications. So again, we're bringing that capability to the heat network world. The platform also has the ability to introduce payment flexibility as well. So where we have the units installed, we can measure the consumption of the units, apply tariffs, and meter and bill those customers effectively. In times of austerity that we're in now, customers can also understand how they're using the system, when they're using it, and what the costs of operation are as well. So it gives customers that absolute visibility and control of how to use and understand and pay for their heating. So what we have on this slide here essentially is a snapshot of the Vital Glass digital platform. So what you can see on the screen is those orange bars represent an individual HRU and metering point. So we're picking up a number of parameters off that HRU. So we have a timestamp which shows us start period, end of period, but we also can see what's being used and consumed in those heating periods. So that gives absolute visibility of what customers are using. We also have the ability then to understand how customers are managing, whether their payments in their accounts are up to date, or the tariff that has been applied to their work is appropriate as well. We can also take flow and return temperature information off the HRU and the sensors within it. So that allows us to also identify any network performance problems that might be occurring on that particular leg of the network. So again, that gives us the ability to intervene and make sure those networks are continuously optimized and improved and operating at the best they possibly can be. So the integrated platform gives us that enhanced customer service. So those customers who've got a connected HRU can communicate directly with the meter and billing team here at Vital Energy. They can ask questions to us through the digital portal. They can look at their accounts. They can also report faults if they've identified something we've not picked up in terms of the monitoring that we do on the network. And again, we can get those things booked into the system, and those customers can benefit from a first-time fix. So we can, once we've got notification of a fault, either through our own means or through the customer, we can look at the HRU and appliance that's in the property. We can look at the parameters. We can remotely change some of those parameters if that would fix the problem. But what it does, it means that when we do attend the site, the customer gets a first-time fix for any potential problems that might be on that system. So we're not guessing. Well, every time we go to a property, we know exactly the nature of the fault and the components that may be needed to fix and get that system back operational and performing at its best. So we also have the ability with the access to data to understand the overall network efficiency. And we also get the ability to understand the peaks and troughs that might be occurring on a network. What the visibility and access to data does is gives us the option to smooth those demand peaks and troughs that you might get on the heat network. So we can see roughly how systems are being used. This is also influencing our system designs going forward. Once we know how systems are used in practice, we can start to apply those diversity curves that we're seeing in reality. And our future designs and developments we have take that data. So it means that we are designing networks now to much more accurately and efficiently. So again, we can sort of hone down into the exact sizing of appliances, what those demands are going to be, what those peaks are going to be, and we can manage those out and smooth those. So it gives us absolute visibility of network performance and the ability to influence the future efficiency of the scheme. So I said earlier on the first slide that the ability to understand the heat network and to have an optimized heat interface unit that works at lower temperature gives maximum benefit. So where you've got a low temperature heat network and you have a HRU that's optimized to work at those lower temperatures, gives us some real benefit. So this slide here is looking at the Queen's Quay network up at Clydebank in Scotland. So at Clydebank, we have 2 water source heat pumps that are extracting river water from the Clyde and upgrading that for useful heat into the heat network. So what we're seeing in reality is that where the HRU is optimized to work at those lower temperatures, we're getting a 1.5% efficiency benefit for every degree of delivered heat. So that is that's reality. So we do practice what we preach, and we do see the outcomes that we expect from these schemes as well. So having a HRU that's optimized for that lower temperature is delivering significant benefits in terms of both carbon and cost efficiencies of the network.
Cool. Glenn, do you mind if I ask you to sort of wrap it up, because we're running about 3 minutes over and we're running on time.
Okay, yeah, so this is essentially the last slide. Is another scheme we'll be doing at Leeds. Again, this is more of a conventional system, but again, what we have here is the Glass Digital platform supporting customers, and we're getting an awful lot of data there, which is again helping us to maximise and optimise how we operate that heat network.
Super.
We'll leave it there.
Excellent. Thanks very much indeed, Glenn. Much appreciated. A very interesting presentation about your integrated offering.
Thank you very much.
So, Glenn, if you can step off the stage, and we'll ask Odessa Ahmed from Sycous to come onto the stage to talk about their innovation orbit. So Odessa, if we can ask you to join the stage. Tom, if you can pull the slides down, and we'll put Sycous' slides up, that would be super. Thanks very much indeed. Cool, excellent. Okay, do you just want to kick off, Odessa, and I confirm that I can hear you okay?
Yeah, thank you, Simon. Can you hear me okay? Perfect. Cool.
Perfect. Thanks very much. Over.
Brill, thank you. Hi, everyone. My name's Odessa. I'm the Business Development Manager at Sycous. So Sycous are a metering and billing company, and we provide an end-to-end solution for hardware, engineering services, ongoing billing services, and maintenance. So Sycous has kept the same ethos since they started, which is ensuring our solutions are open protocol and future-proof. So using our in-house designed and developed billing platform, MabDeck, Sycous are now providing metering and billing services for almost 50,000 heat network payment points. We understand that there's a lot of benefits to pay-as-you-go solutions as well. It allows you to support the resident to manage and control their energy usage and the costs associated with this. But we also understand how pay-as-you-go solutions are used across the UK to reduce the debt risk to housing associations and local authorities, especially where there are remote options to switch a resident from credit billing mode, so that's where the resident's paying at the end of the month, and pay-as-you-go where residents are topping up in advance to use their system. Traditionally, these solutions have involved a high capex and a high opex. Pay-as-you-go systems require extra hardware. So within the properties, you need the pay-as-you-go unit, the prepayment valves, and in-home displays. So essentially, these are additional costs where residents are already financially struggling. So with this in mind, Sycous created a cloud-based pay-as-you-go solution, which was backed by Innovate UK. So this solution is called Orbit. It's what I'm talking about today, and Orbit connects communal and district heating networks to a modern, more cost-effective and an open protocol metering and pay-as-you-go system. So how does it work? Orbit uses LoRaWAN communication, which is a wireless communication solution. So Orbit can work with any open protocol metering system with suitable control and API points. We've developed a number of options. One of these is LoRaWAN, others could be hardwired M-Bus. So you might be familiar with wireless M-Bus, and LoRaWAN follows a similar concept, but it has a much wider range of communication and sits a part of the Internet of Things. The further reach of communication reduces the number of gateways and obviously the costs that are associated with the gateways that are required to retrieve the data from the meter points. So the hardware does follow a similar concept, which I'm sure we're already aware of. Each property will have a meter to monitor and calculate the usage within the property, and then this sends the information back to a central gateway. But to create that two-way communication to enable us for the valve to close once the money's run out, a relay device is also installed. So the relay device is a really small, cost-effective device. It typically sits near the heat meter and the valve, and it enables remote control. So this new technology not only allows us to provide a pay-as-you-go solution at reduced cost, but it also opens up the opportunity for remote control for the residents as well. So Sycous are able to supply, install, and maintain these systems. In replace of an in-home display, residents can access all of their information via an app. So including all of the typical usage data the resident would see on their in-home display, but it also allows the resident to make direct top-ups from the app or view a virtual payment card to top up in-store if that's what they prefer. And the use of an app also means that we can provide direct links to the support, live chats, and directly to our customer service team. And it keeps all the information for residents in one place and just improves the streamline of the service they receive. So Orbit provides all the features you may already be familiar with from a pay-as-you-go solution. So for instance, Orbit enables you to add multi-utilities to the system for pay-as-you-go functionality or monitoring. And it also lets you remotely change the system from pay-as-you-go to credit billing. And it's also designed to meet all metering and billing regulations. But as Orbit follows our open protocol ethos, it means we have open APIs. There's no lifetime manufacturer fees or head-end system fees. And alongside the reduced cost of equipment and the minimal maintenance that's required, it's a pay-as-you-go solution which has lower capex and lower opex costs that are typically associated with these pay-as-you-go systems. And like all of our other solutions, we use open protocol hardware, which can be purchased by various vendors, and a true clean break can be achieved. We pride ourselves on our customer service, so to our clients and our residents, and we know that an open protocol ethos creates competitive services with the accountability. And by integrating the system with the Sycous app and MabDeck, we're also able to add multiple tariff modules and smart or comfort tariffs. So by utilising the LoRaWAN communication, the gateway on the site enables you to continue to develop a smarter building. So not only does LoRaWAN provide this enhanced data collection network and give you 15-minute granular data, it also allows you to add various other monitoring devices without needing to upgrade or add additional gateways. So for instance, sensors can tell you if a door or a window is open or closed, And these can be connected to the system to monitor and improve the energy usage across the system. Of course, if the heating is on high and the doors and windows are open, there's a real easy way to reduce the energy usage immediately. Parking sensors, fire alarm sensors, temperature sensors, and humidity sensors can all be added to the same communication and the same data collection which Orbit's communicating on. This means that not only are you providing a pay-as-you-go solution, you're also proactively monitoring the building as a network, as a whole network, and you're able to use the data from this to improve energy usage across the building. So for instance, using the pay-as-you-go solution alongside temperature sensors, you can provide incentivized tariffs where residents have to keep a minimum dwelling temperature of 14 degrees, which prevents mold and also prevents further costs for maintenance. Future developments to Orbit as well will enable all of these sensors to be integrated into one app, which means there's more information and more control to all users, including the clients and the residents. So the solution we have for a cloud-based pay-as-you-go system, but it's also important to consider what the residents will receive from this. So Sycous have heavily invested in our resources to the residents, and we've also spoken directly with our current residents, and we've worked with them to get a lot of feedback. So as part of this pay-as-you-go offering, residents will also be able to access all of their information for their account and their usage information directly from the app. It's also where residents can top up their pay-as-you-go system or use that virtual payment card in store. Usage information is also available on a consumer dashboard, which also includes past usage and annual statements. So alongside their information, all consumers can receive access to our My Sycous portal as well, which you can see on the screen. This is a completely self-serve website where residents can inform our billing team if they're moving in or moving out. They can update any of their information from this platform. Also, they can see all of our blogs and frequently asked questions. They can download the user guides from the equipment that they have in their homes, or they can speak directly with our customer service team via the live chat. All of our resources use Recite Me overlay, which means it's accessible to everyone. So all consumers can change the size of their font, the colours on their screen, change the language, or even have the page read out loud. We also recognise that the data we use to provide this customer billing service belongs to the client. So all the clients have access to their data at any time using their own logon. Mabdeck users can access the data, generate their own reports, and view the notes between our billing team and your residents. And Sycous also provide a fully white labeled service, so all documents and consumer dashboards are branded with your logo, and our team even respond to calls and emails as a member of your company or organisation. And when we begin onboarding, we really like to attend the sites and work within the communities we're providing the services for. So that means we're showing live demonstrations of the equipment, we're providing access to the online resources. Usually this is in communal spaces or sometimes just in our pop-up events and pop-up gazebos that you can see in that picture. So all of our services alongside Orbit provides a really innovative, cost-effective solution. And if you'd like to know more or see a demonstration of their system, please let me know. Thank you.
Brilliant. Thanks very much indeed, Odessa. Thank you from the chairman for keeping to time. So that was much appreciated. And thanks very much indeed for a very intriguing presentation. I'm sure they've received lots of questions. I possibly see one just popped up in the chat. So Odessa, thanks very much. If you'd like to leave the stage, Tom, if you'd like to pull Odessa's presentation down. And we'll now ask Miles Bowker to come onto the stage, Miles, who will be talking about Miles is from Armadillo Analytics, a new company, and be talking to us about what Hub is. So Miles, do you want to kick off? Just make sure I can hear you okay?
Yeah, thank you very much, Simon. Can you hear me?
Perfect, no problem at all. Over to you.
Great stuff, thanks. Hi everyone, my name is Miles, and today I'm looking forward to telling you a bit about Armadillo Analytics and our new innovation that we're building in the industry. But before I get onto the innovation, I'll just give a quick background to us. We're a team of engineers spanning various disciplines from civil to electrical to data engineering and data science. And before starting Armadillo Analytics, I was the general manager of a large district heating company. And from an operational perspective, at that company, one of the primary challenges that we faced was getting end-to-end data and a holistic view of our energy networks. And those challenges primarily being that there are multiple sources of data in multiple formats across our networks and multiple platforms that you need to log into to get that data. That was a time-consuming process and prone to error, and it only gave limited real-time monitoring and analysis opportunities. It was not scalable, and it was something that we needed to solve. So if those are the challenges, then the dream is to have a highly scalable, synchronized, and sustainable energy platform where millions of smart physical assets can interconnect. And the result of that is a large array of data-driven energy products and services that incorporate new technologies and efficiency improvements. Now, that extract comes from a Deloitte report on energy as a service, and that report is a few years old, and we still don't have a solution. We don't have a connector, and that is a problem that needs to be solved for us to unlock the potential of data and interconnectedness in our industry. And it's from that need that the Armadillo Hub was born. So before I go into the detail of the Hub's technology stack, the high-level overview is that on one side, we have bi-directional connections with data generators and connected assets like smart meters, building management systems, and the like. And on the other, we have neatly consolidated and structured data, some very powerful modules, and a REST API. And the beauty of the hub is the infrastructure on which it's built. So it's designed from the ground up to be API first. And this is what makes it so effective when integrating with third parties. It's hosted on Microsoft Azure, and it uses Apache Kafka and Kubernetes to create a very high-speed data engine with a high throughput in both directions. Its storage infrastructure is unique too, and we make use of both key value and blob storage to hold everything from high-frequency time series data to documents and files. This then gets overlaid by a graph database, and that enables clever queries and analytics. Graph networks excel at relationships and links between data, and they allow highly flexible and evolvable structures to be overlaid on top of the same data. So this structure means that the hub is super scalable in terms of both the volume and the velocity of data that can pass through it. It allows us to handle multiple high-speed concurrent integrations and consume data and both controlled devices, such as ingesting CSV files that might be populated with manual meter reads or temperatures or commissioning data, bi-directional integrations with meters such as Alvaco M-bus networks. And why I say bi-directional is because, like with Orbit that Odessa presented before me, the hub enables you to provide a thin client pay-as-you-go solution and push commands back through those connected meters to control relays, etc. We also integrate with the different types of smart meters that we have in the industry and with IoT devices using the MQTT protocol. We integrate with electronic HIUs, with building management systems such as Trend and Tritium, and more. Basically, if there is a data source available, the hub can connect with it. So now on the left-hand side, these are all the connections that allow you to connect with your end-to-end energy network. But you still need somewhere to interact with your data. And there have been solutions before where platforms say they can integrate all of your data, but then usually you're locked into that platform and its tools. And that is not what we're about. And that's actually precisely what we've set out to solve. We believe that everyone should be able to use the tools of their choice. So we offer various modules such as connectors, and that allows you to connect to databases of your choice, such as Azure SQL or InfluxDB, and we push high-speed data streams in a structured format to those databases. On top of those databases, you can use applications like Power BI and Grafana to analyze or react to and monitor your networks and assets in real time. You can raise alarms for operational reporting, and you can do advanced analytics in Grafana. You can also use Power BI for business, client, and KPI reporting. And you can have all of your platforms sitting on top of the same database. So you have all your data in one place and use different tools for different purposes, not be locked in on a tool that might be limiting for you. So Grafana and Power BI are only 2 examples of the many options that are available. And I should mention that we also push data to REST API endpoints. So we can push data to virtually any platform, for example, some of the platforms that are supplied by other UKDEA members, which are really good. We have a powerful REST API that can be used to query the hub or hit it with a command, and we handle the mapping of that command. So for example, you can hit the hub with an API call to say, please top up meter 123. We do the mapping of what meter 123 is, which smart meter platform the command needs to go to, and we'll push it through and feed back the response. So this allows you to use the hub with any platform of your choice and enables you to easily take on sites with new types of meters that you may not have used before. And previously, that's been quite a challenge in the industry. So we also connect with Neo4j, which is a graph database management system. And as mentioned earlier, that allows you to flexibly overlay metadata on top of your Energi network data. And for example, if you look at that image to the right, if you imagine the blue nodes being energy centers, the main red nodes are substations connected to that energy center. And then the final nodes are the HOUs connected to those substations. And by creating a graph like that, you can easily create queries on your database to work out VWATs in different segments of your network and to really do some very powerful analytics. We also have a value-adding computational module that undertakes machine learning on your data stream and can add insights and health metrics to your assets. And there really is an incredible amount it can do. And I think it probably necessitates a session on its own to explain it. But a quick example is that we can proactively predict common faults and issues in the network and serve them for you to see in your dashboard. And then you can take rectifying actions before things go wrong or before a customer calls. And lastly, we have a metering and billing module that has both a customer platform and a progressive web app for mobile devices, as well as a business platform for managing your network, your accounts, your tariffs, etc. Again, there's loads of functionality in it. And if it's something you're interested in, please do reach out. There isn't time to go into the detail, but a high-level overview is that it is a multi-property and multi-utility platform, so you can build virtually anything on it. So this is our innovative tech. It is a hub that allows you to connect to all the data sources, to control those, and to bring all your data into one place without being locked into using a specific tool or platform. But the hub is only half of the innovation. The other half is the community that we're forming around it. We have an ecosystem of like-minded companies and clients that are joining and connecting to the hub so that they can add value to the sector. And ultimately, our goal is to get the right data to the right people in a very secure and permission-based way so that those people can make the right decisions and make a difference and improve efficiencies and ultimately improve the services we offer to the industry. So if you'd like to join the community, or if you'd like to build a plugin to the hub and create a value-adding service, please do feel to reach out. And my name is Miles Bowker. My email address is miles.bowker@armadilloanalytics.com. And I hope you enjoyed the presentation. If you have any questions, please feel free to send them through.
Brilliant. Thanks very much indeed, Miles. Thanks for a very intriguing presentation. It's an interesting concept you've developed there. And as you say, any questions, please put those in the question session on the bottom of the board. So thanks very much, Miles.
Thank you, Simon.
Step down now, and we'll bring on the next presenter. So the next presenter is Soulla Paphitis from, sorry, Soulla. From,
it always happens, it's fine.
It's from Danfoss, who'll be specifically talking about their lean heat software and network digitalization. So as I can hear you perfectly, I'll step away and leave you to present. Thanks very much.
Thanks, Simon. And thank you all for hanging on. I know a lot of you were hoping to be off the call by now, but I'll try not to keep you too long, and I will definitely stay within my 10 minutes. So thanks for joining us all today. My name is Soulla. I am the National Sales Manager for District Energy for the whole of the UK and Ireland. And I'm going to talk to you today about some innovative software that we have available. So just really focusing on Danfoss Lean Heat software suites, and this is for end-to-end optimization solutions, and it's serving district energy systems and the connecting buildings. So we start from the demand side of sorry, I've lost my slide. So we start from the demand side, which is obviously the building side, using lean heat building, and this harnesses the power of digitalization through AI technology, and it's used to optimize energy consumption within the building, and it increases the operational efficiency and puts the building control and maintenance back into the building owners or the maintenance team's hands. And then we move into Lean Heat Monitor, and this is our form of a light BMS system, and this is really focused on the plant material within the building itself, giving real-time data, and it gives you the positioning of the valves, which pumps are operating, at what position they are, and it really allows you for that interactivity with your building from any digital device, and you can tap into a number of different buildings around at the same time and get live data streams and really understand what's happening. You can also change set points and make changes from any digital device as well. Lean Heat Network is a thermohydraulic modeling tool, and this is developed specifically for use in district energy systems, and it's to support the planning, design and operational processes. So using Lean Heat Network, you can plan how your heat network will look. Authorities, local authorities, heat utility companies can start to look at where best to lay pipes or on what route, how to connect new buildings, and start to run different types of simulations and to see what a network would look like and the impact that other buildings would have on the network in a much easier and efficient way than using spreadsheets and old calculations. Lean Heat Network is also an online operational tool, and what this does is it takes data from live set points. So we've heard today about taking data from energy meters and different set points from around a network, and Lean Heat Network can do that through API, and it actually allows you then to start to create temperature and pressure optimization for the whole network, giving you a much better and tighter control, ensuring that you're only using or only creating enough energy that the network actually desires. And then Lean Heat Production, this is a bolt-on really for Lean Heat Buildings or Lean Heat Network, but it can also be used as a standalone product. And this is an AI technology, and this is for optimizing production. So across all of your production, if you've got a multi-sourced energy system, it can help you to create a production planning for those. And it's also talking about load forecasting. So it takes historical data and it understands where there's a demand and where there's a need, and how much energy is going to be needed at a specific time. And what the benefit of this solution is it really allows you to use the cleanest, greenest energy first within your network. So I'm just going to run through a couple of case studies with you, with a couple of the softwares that we've talked about. So this is a study that we did on Lean Heat Network software, and this was with a heat network consultant, and they approached us and asked us to help them with a feasibility study of a network, and this is up in North Yorkshire. So the project itself consisted of 3 commercial properties and 46 domestic dwellings, and these were all going to be connected up to a main energy centre. So we worked with the consultant on the designs, and we inputted all of the data that they'd given us and that they had available. And what we did through the software is we created some boundary conditions, and this was adding kilowatt ratings, supply temperatures, pressures, returns, and we started to create a time series. So a time series meaning there's, in a domestic dwelling, there's a normal or I would say we're starting to get back to what was a normal demand of energy. So your early morning peak to your evening peak. So we were able to start putting those kinds of data within the software itself. And we were also asked to use a specific pipe manufacturer's pipe material, to which we then reloaded their catalog into the software as well, which then allowed us to start to create some real data behind what the network would look like. So we run some simulations, and you can see from the slides that are here, I'll talk you through what these slides are actually showing you. But what we did was, as part of the feasibility study, the consultant was able to take snapshots of the network itself and actually incorporate that into their return to the client who was looking at starting this network up. So you can see here on the first picture, we can see, I mean, I don't know how far you can drill into it, but you can start to see the data for the plant material. So giving you your kilowatt outputs, your temperatures, your returns, your pressures and things like that. And then we've got the next picture, which is the pipe size and the node power. Now each area or each consumer will have a node, and this is how we select how much power goes to that particular dwelling or building. And what you can see on the color charts there is the different loads and the different sizes of pipe that have been selected. And then if we move on to the next slide, you can also see that from this we were able to create a dashboard which allows you to look at different levels and different parts of the network itself, and really gives you this visualization of the data rather than it just being in a spreadsheet or a table. So the picture here shows that we've got the heat losses, so it will show you the total flow of heat losses and the flow of the energy that's needed from node to node. And then you've also got the time series. So as I said, you know, we're going back to that sort of normal where we would expect to see a high peak demand in the morning and a high peak demand in the evening. And we're able to input that data and really start to understand how the network would look. It's very, very complicated and very difficult to explain in just a few minutes. So one of my team has become a expert in this. So if you're really interested in understanding a little bit more and having a presentation on that to yourselves, we'll be more than happy to organise that for you. And then just moving on to one of the other softwares, in my view, district energy really is the focus of us and how we're going to decarbonise our country. And it's always great for us to have these softwares and these technologies that allow us to take data and allow us to understand what's happening. But actually what we really need to do is we really need to understand the buildings first. So lean heat building is a AI technology which allows us to really dig down into the buildings that will be connecting to heat networks or are connected to heat networks. And these are numbers from a real life case study that we're doing in a UK building in central London. It's 8 different blocks with 114 different apartments, and we've censored around 35% of the apartments in order to take our data feeds. And what we do is we monitor the temperature and the humidity within these apartments to give us an average mean temperature. The authority who owns and operates this particular block or a set of apartment blocks has set a set point of 24 degrees. So at no point can the temperature within the apartments drop below 24 degrees. And we operate the plant room. We've connected into the system there, into the BMS system, and we are in control of a 3-port valve, which allows us to either push energy into the blocks or divert it away where it's not needed in order to keep the temperature at the set point that's required. We all know that with old buildings, we either have a lot of underheating or overheating. You know, in the winter, they generally might not get hot enough, and in the summer, they're generally too hot. And we pump energy that we don't necessarily need. And what you can see is on this chart here, you can start to see the difference between what energy was being consumed prior to us taking control of this building, which is the dark red, and then from us taking control, which is the brighter red. Now, around the winter period, you can see that the savings are much less, but you would expect to see that during our main heating demand. So what the software is doing is it's taking all of the data from the sensors, from the plant room, from the required amount of heat, and it's rationalizing it, and it's optimizing it, and it's saying, I don't need to deliver this much energy to that building because there's no requirement for heat. So the data here is for around 11 months, and within 11 months of operating this software in these blocks, we saved 600 megawatts of heat, which equates to around 156 tons of CO2 and around a £24,000 value saving. This is prior. This data and these numbers are prior to the gas crisis that we find ourselves in today. So if you can imagine, if we installed this into a number of buildings now, how much of a financial saving that would provide building owners. That's my last slide, I believe. Oh no, this is just a graphical view there that explains the same thing, but you'll get the presentation slides afterwards, so you'll be able to look into that in a little bit more detail. If you've got any questions, I'd be more than happy to take them, or if you need anything, I'll drop my email in the chat function and you can get in contact with me.
Perfect. Lovely. Thanks very much indeed. I see your email's just there at the end of the presentation, Soulla, so that's really great that people can contact you. Thanks very much indeed for keeping to time. Much appreciated. A very interesting presentation. So I'll ask you to leave the stage, and Tom, if you don't mind putting down Soulla's slides and putting Micronics up. And the next person who's going to join us is James Charlton, who's going to do hopefully quite a quick presentation, because we are running quite tight on time now, about bulk metering, not as scary as you think. So James, I hope that you're there. And just to confirm, we've got James's presentation and then one further one from Dirk from Zero Friction, talking about the innovation SaaS. So James, are you in the room? Hopefully you are, and we can quickly pull you onto the stage. If you've left the room and you are here, I can see.
I'm here. Sorry, my camera's not working, so you won't be able to see me, which is a bit of a pain.
That's all right, James. Not a problem at all. I don't mind, as long as you're there. We can hear you perfectly, so I'll hand over to you. Thanks very much indeed, James.
Brilliant. Thank you. Thank you again for everyone for listening and participating today. So Micronics is a non-invasive ultrasonic metering manufacturer. And really, I just want to talk through what I think is one of the key elements of the industry we're in district heating, community heating, which is the bulk metering, and actually why I feel it's such an important area and why we need to kind of not lose focus on this as a low-hanging fruit of understanding the networks and how it works. So in simple terms, what is bulk metering? What are the challenges that we're facing behind it, and ultimately what is the goal of what we're trying to achieve? So in simple terms, bulk metering, the heat metering networks, district heat networks must feature point of entry meters for each building and bulk meters central plant and supply energy to each building. And this is actually a statutory requirement. So from our customer bases and who we speak to in our clients that we work with, this is a must-do across the whole entire network. So the challenges we face, obviously, financial is one of them. Money is a challenge with the additional costs that people receiving, especially this year. The budgets are getting tighter and tighter, so we need to look at that financial aspect of the challenge, understand what the capacity is to make these improvements and what is out there that can help them achieve that as well. There is the civil aspect of it. So again, years ago I did a survey at a local authority in London, and we found point of entry meters actually in flats of the residents. So as you can imagine, from that point, getting to these meters or potentially other points of entry which are under the ground, which require digging up the roads, is civil cost again, which impacts the financial capacity that is had on being able to deliver and actually make these improvements. Obviously, time is a factor as well. You know, what we don't want to do is we don't want to disturb residents too much. We don't want to actually make it so they feel like they're being impacted and there's always disruption to their service. And obviously the residents are key to this, because at the end of the day, they're the ones that are affected by what happens. They want to really know, you know, what are we doing, why are we doing it, how it's going to affect them, is it going to make an improvement? So, you know, when I've spoken to residents and done residential presentations on bulk metering and point of entry metering, and while we're doing it for them, a lot of it is their fear is they're going to lose out and actually going to be worse off than what they are now. And then you've got the technology. There is multiple options out there. You know, Micronics itself is a non-invasive ultrasonic technology that can be used in conjunction and in line with the district heating networks to actually monitor these systems. There are different comms options out there. There are different ways of getting the data back to a centralized viewing point. You know, we've seen today in the presentation, there are different ways of looking at that technology and how to get that information out. But the information that comes out of that is the key part, because once you've got the data, there are several factors of that data that are important for me. You've got the understanding of what's actually been generated by the boiler itself, how much energy is actually being generated. Then with the likes of, you know, the companies that are looking at the meter and billing side of it, how much is actually being used by the residents, and then what you have left over from that with monitoring the overall system, is you can actually understand what is left. So what are the losses, what is being dissipated in heat, what is not being utilized efficiently within the system, that is a loss and a waste of money and energy. That's really kind of the challenge that are in place. So once we know that data, then, you know, really what is it we're actually trying to achieve? And this is kind of just putting obviously back this kind of story of what we're trying to achieve, and, you know, really kind of put this back in people's minds. Is the goal of this ultimately is to build and understand the energy profile of your networks. If we understand and have a baseline of what we're doing and how we're doing it, all the little improvements that we can make throughout the system. So more building controls, more residential controls within the building themselves, improving the system's efficiency on the pipe work, improving the water quality, all these areas, you know, actually make a difference to how efficient that building is. But obviously we need that baseline and that understand to be able to show that improvement. To me, it allows people to be proactive with their maintenance and the system updates. So instead of being reactive to problems that come in or residential complaints, we can be proactive and actually look at how efficient that system is. That also allows us to be proactive in making incremental improvements, like I said before, on how our buildings work and actually how we use that all together and make those improvements for our clients and for their residents. Obviously, the other big one, and they're buzzwords, but there is an element behind it. If we can improve the efficiency of the system, we can reduce the amount of energy that's being burnt, and ultimately we can reduce the amount of energy that has to be used. Reduced energy, reduced costs means reduced CO2, reduced carbon footprint, and more sustainability. And that reduction there, and that's energy saving costs, it then goes back to previous ones where they can make those system updates to make them even better, to add in additional controls that can actually make the system work even more efficiently. And really the key one for me, and this is the big one overall, a lot of the residents that are in these buildings are in poverty, energy poverty areas. The idea of having district heating systems, community heating systems, is to reduce their energy costs. And ultimately, with all these improvements, having that baseline understanding and making all the improvements that have been suggested and you know, listening to everyone today, ultimately is to reduce energy bills for the residents. And if we can do that, then I think we've actually achieved a big change in the industry and in this district heating market. And that is me. Thank you very much.
Lovely. Thanks very much indeed, James. Much appreciated. Very intriguing and interesting presentation. So thank you, James.
No worries.
I'll ask you to leave the stage now, and then we'll call up our final presentation, our final speaker. So it's Dirk from Zero Friction. So good morning, Dirk. Thanks very much for bearing with us. Sorry, we're running a little bit over time, If you just want to kick off, I'll just confirm I can hear you okay.
Okay, thanks. Good morning, Simon, and thanks for having us.
No worries.
I'm Dirk Michaels. I'm the CEO of Tangent Works, and I would like to talk to you a bit about what we are doing. So actually, what we do at Zero Friction is that we want to impact the energy transition of the collective heating and cooling market. Zero Friction was founded by customer care and billing veterans that had a dream to deliver a really game-changing solution as far as the customer care and billing scenario goes. And this is really related to ensuring that a nightmare of implementation can be given away. And that's, I think, the core of our value proposition. Now, more than 60 customers are on board with our solution, and that includes giants like EDF, Veolia, Energi, Equins, etc. And we are now really starting our international expansion. So we started off in mainland Europe, but currently we are setting up offices in various places throughout Europe and also in the UK, with each time the goal to ensure that we can really meet the local legislation. So our proposition is basically one of being compliant with the local legislation of any country that we are going into. So what do? Well, we transform the way collective heating and cooling companies interact with customers. So we change the customer care and billing process of our customers, and that those can be cooling and heating suppliers, but it can also be property managers or landlords and service providers, and that's regardless whether they have, let's say, 10 connections or 50,000 connections. We really can transform the operations for them. And how do we do this? We do this by bringing digital transformation to our customers, and that allows them to engage with their customers on a whole different level. It also empowers the employees of our customers. It optimizes the operations. And finally, it also transforms the products that they can offer to their end customers. Now, how do we do this? Well, we do this by offering a software as a service solution. So it's a pure cloud solution, and many people regard us like the Spotify of the customer care and billing market. And we really cover the meter to cash cycle with an integrated customer portal and an integrated customer app that is really liked by our growing customer base. Now, secondly, you can decide to run our solution yourself, and then you just use our SaaS solution, or you can let Zero Friction or its partners run the solution on your behalf as a business process outsourcing services. And this obviously removes the burden of setting up the organization yourselves. And the organization of the application is in such a way that you can integrate it very easily with your existing environments like finance applications, customer care, and CRM solutions. That's all very, very much possible. Now, obviously, why are we doing this? I think this is pretty clear. I'm not going to spend too much time on this slide. Yeah, we all know that 50% of the energy globally is spent on cooling and heating. If we want to really go to this net zero, this is going to be a challenge. So we need to make sure that we can meet that goal. And to meet that goal, we need to do the things differently. And we at Zero Friction really believe that if we want to do that, we need to make sure that we get the customers on board as well. So much of our solution is about customer intimacy and about customer experience to ensure that we get our end customers on board with the solution and etc. Now, if you look at customer care and billing solutions, and obviously there has been quite a bit of evolution over the last, let's say, decades. So if we think that we can revolutionize the market, so why is this? And why do we think we can really change the paradigm? If you look at the 1.0 as indicated on this slide, then we're talking about monolithic solutions, and people who have been involved with this in the past, well, they know that in the past we were doing things with mainframes and large computer systems to ensure that we could do customer care and billing. That's not what is on the market anymore, but we still have a lot of 2.0 on the market, which is service-oriented, and it's about integrating packaged applications to get things going. What we are doing with Zero Friction is really ensure that we have customer care and billing 3.0, where you can actually benefit from digital transformation and where the focus is on customer experience. And some of the speakers before me already mentioned things like Microsoft Azure and the cloud and the power that is there. And I think that's amazing, the power that it can offer to any of our customers. And obviously, this does not mean that you can always decide to build your own cloud application. But as we heard before in the analytics presentation, for example, if you want to do that and build all that knowledge yourself and set up your own teams, it's a very costly proposition. And that's not what we're into. We want to offer this really as a Spotify towards the market. Now, if you look at the next slide, people who have been involved with customer care and billing will recognize a lot of the points that are mentioned here. Yeah? And I'm not going to read them out all because I'm sort of the person who is in between now and your lunch. So it is for sure the case that a lot of the customer care and billing solutions have been hard to implement. Me personally, I've been working in the sector for 40 years, and I've seen a lot of projects who have gone wrong, who didn't meet the timelines, who didn't meet the budgets, and it can be enormously painstaking. Yeah? And still, a lot of projects are too much IT-driven, and there is a broad gap between what the business actually requirements and what the IT people are delivering. Yeah? And you often also get stuck with the local legislation. The local legislation can be a hurdle that is very difficult to take if you don't have an application that takes care of this. And that's why we also decide we only want to go into a market if all that functionality is available. And that's where we really want to make a difference. So if you look at this slide with the pain points, these are the areas that are core in the way that we design our solutions and we want to go to markets going forward. Now, what are the functionalities that are provided? Well, first of all, there is obviously customer management. You want to know who is your customer and you want to keep all the information on the customer in the system. So this all goes into the cloud environment. Does this stand alone? No, we can integrate the customer management with solutions like Salesforce, like Zendesk and Freshdesk or Microsoft Dynamics. That's all perfectly possible. But once you have identified your customer, then it's about contract and product management. Obviously, from the legislation perspective, there are products that you can offer, so those can be added into the contract. But if you want to set up your own and configure them as you wish, then that's perfectly possible with the solution. Now, on the other hand, on the top level corner of this slide, you'll see measurement and consumption data. We can actually interface with any metering device on the market, whether it's Camstrup or it's Flamco or it is Siemens, it doesn't really matter. We can get that data in, and that data can then be combined with the contract and products to create bills. Those bills are then passed on to accounting software so that you know what has been billed. And we also cover the complete payment process. And the nicest thing, I think, is the customer portal. And with customer portal, we refer to an actual self-service portal, but also an app which runs on a mobile phone that allows you to see all that data. And this goes beyond just the traditional electronic profile presentment and electronic bill presentment. It's also about how can I set goals for my end customers so that they can decide what their goal for the energy consumption for the coming week is, for example. And that's extremely powerful, I would say. Now, what are the values that we are offering? If you look at them, well, it's all about generating impact in this market and ensuring that we can meet our CO2 goals as a world, I would say. The solution is extremely easy to implement and use. And when I talk about easy to use and implement, easy to implement means that we are talking about implementations of weeks or months, not about months or years. So you can be up and running with this platform extremely fast. The other important thing is because you can decide whether you implement it yourself and run it yourself, you can also use our BPO services from ours and our partners to get up and running with the solution. And actually, we are continuously looking to broaden our partner network of companies in local countries to ensure that we can deliver our solution end to end. Secondly, we have an out-of-the-box process library, which is extremely strong, and that focuses on customer experience. And I will show you one slide on that in a minute. It's built on solid digital transformation, so this means that it's a really native cloud application. It uses data insights and AI technologies from the Microsoft Azure platform. And lastly, it also has a controlled cost, which makes it very predictable in terms of pricing. So it's just like a cloud service that you pay for, just like, as I said before, in the Spotify case. Now, when I talk about business process outsourcing, and it's about how are we going to run the solution, and that's what you see here. This is actually a library or a subset of the library that we are positioning into the market, and you see that it kind of covers meter reading to cash collection, and it also has customer interaction, and there are various kind of packages that you can choose from to offer to the customers. All those processes have been fully documented. So this means if you want to run it yourself, you just pick up the process library and you can start using it to run the solution. And also, if you want to run it as a BPO service and ask Zero Friction or its partners to run the actual process library, then there's also a clear template on how we are going to do that. Obviously, this is only a short summary of what Zero Friction has to offer. So I would like to invite you to visit our website, get in touch with me, and I'm happy to organize a more detailed presentation and video to give you an insight on the solution.
Lovely. No,
thank you very much.
Thanks very much indeed, Dirk. Much appreciated. Thank you to everybody. So invite Dirk to leave the stage, and Tom, if you want to pull Dirk's presentation down, thanks very much indeed. So I'll just wrap up by saying a big thank you to all of the delegates who were with us this morning when we had some technical problems at the start. A big thank you to all of the speakers who tried where possible to keep to time, and hopefully that you've taken away some really interesting insights into innovations this morning. So thanks again for attending, and Tom, if you don't mind pulling the event to a close, that would be most appreciated. Thanks very much indeed.